You're watching Tech with Shaping Pixel, and this is the AI-103, Developing AI Apps and Agents on Azure full crash course. Inside this session, you'll find 44 real exam-style questions, 100 practice questions, and a complete PDF study guide available at shapingpixel.com. Whether you're building AI apps, agents, or preparing for certification, this crash course gives you everything you need to master AI 103. Let's begin your journey to becoming Azure AI certified.
The Microsoft Azure AI Engineer certification is designed for professionals who build, manage, and deploy AI solutions using Microsoft Foundry. This certification validates your expertise in leveraging Azure's powerful AI capabilities for real-world applications. To succeed, you should have experience developing applications with Python and a solid understanding of general artificial intelligence, generative AI, and Azure services. This foundation ensures you can effectively utilize the tools and technologies required for the exam and in your daily work as an Azure AI engineer. Your main responsibilities include planning and managing Azure AI solutions, implementing generative AI and agentic solutions, as well as developing computer vision, text analysis, and information extraction solutions to address business needs. In this role, you will collaborate closely with business stakeholders, solution architects, data scientists, DevOps engineers, and cloud security engineers to design, implement, and maintain robust AI solutions. Develop generative AI apps in Azure. Plan and prepare to develop AI solutions on Azure. Artificial intelligence is transforming how developers build solutions, especially with the rise of generative AI. Creating effective AI applications now requires combining machine learning models, AI services, prompt engineering, and custom code. Key considerations. Before starting your AI development project, it is important to evaluate your options. Consider which services, tools, and frameworks best fit your needs. Think about scalability, integration, and how your solution will evolve. Following proven principles and best practices can help ensure your project's success and long-term sustainability. Microsoft Azure Services. Microsoft Azure offers a wide range of services for building AI solutions. These include machine learning tools, AI-powered APIs, and resources for prompt engineering. Azure's flexibility allows you to tailor your project to your specific requirements. Introducing Microsoft Foundry. Microsoft Foundry is a comprehensive platform designed for AI development on Azure. It brings together essential tools and services, streamlining the process of planning and building advanced AI solutions. Artificial intelligence, or AI, refers to software that enables applications to mimic human-like behavior. Over the years, AI's definition has evolved, but today it's powered by machine learning models that interpret data, reason, and generate responses or predictions. Generative AI uses large language models, or LLMs, to create original responses to natural language prompts. This technology powers interactive chat applications and AI-assisted content creation. Agentic AI builds on this by combining LLMs with specific instructions and tools, allowing AI agents to automate tasks and find relevant knowledge. Microsoft Azure offers a wide range of services for building AI solutions. These include machine learning tools, AI-powered APIs, and resources for prompt engineering. Azure's flexibility allows you to tailor your project to your specific requirements. Introducing Microsoft Foundry. Microsoft Foundry is a comprehensive platform designed for AI development on Azure. It brings together essential tools and services, streamlining the process of planning and building advanced AI solutions. Natural language processing, or NLP, is a foundational area of AI. It helps applications understand and analyze language in documents, emails, and social media. NLP is used for text classification, sentiment analysis, and summarization, making sense of vast amounts of text data. Computer speech and vision. AI can recognize and synthesize speech, enabling natural voice interactions and transcriptions. Computer vision allows AI to interpret images and videos, such as identifying products in a grocery store or generating visual content from prompts. Information extraction and application. By combining these capabilities, AI can extract key information from documents, images, and recordings. This enables solutions like automated expense processing, where details are pulled directly from scanned receipts, streamlining everyday tasks. Microsoft Foundry is a platform designed for artificial intelligence development on Microsoft Azure. While you can build AI applications without it, Foundry's project organization, resource management, and development features make it the recommended approach for all but the simplest solutions. Projects and resource management. In Microsoft Foundry, everything revolves around projects. Each project manages connections, data, code, and other elements needed for an AI solution. Projects belong to a single Foundry resource in Azure, which provides compute power, data storage, and essential AI tools. One resource can support multiple projects, with one set as the default.
Models, agents, and tools. Developers use projects to manage assets like models, agents, and tools. Models include large language model deployments from Microsoft OpenAI and other providers. Agents are autonomous AI entities that automate tasks and collaborate with users. Tools range from built-in features like web search to custom integrations using the Model Context Protocol. Knowledge integration and Foundry IQ. Agents can connect to knowledge stores using data to contextualize prompts. Foundry IQ simplifies integration by creating a single central knowledge connection for your project, streamlining access to multiple data sources. Portal and SDK capabilities. The Microsoft Foundry Portal offers a visual interface for managing projects, while the Foundry SDK enables automation and integration with DevOps pipelines, making AI development efficient and scalable.
When building AI-powered applications, it is not always necessary to start from scratch or rely solely on generative AI models. Microsoft Foundry tools offer a collection of pre-built APIs and models designed to handle common AI tasks efficiently and cost-effectively. Key Tools Overview. Foundry tools include several powerful solutions. Azure Language provides models and APIs for analyzing natural language text, enabling tasks like entity extraction, sentiment analysis, and summarization. It also supports building conversational language models and question answering systems. Azure Speech offers APIs for text-to-speech and speech-to-text transformation, as well as real-time speech capabilities for conversational applications. Azure Translator uses advanced language models to translate text across many languages. Azure Document Intelligence allows you to extract fields from complex documents such as invoices, receipts, and forms using pre-built or custom models. Finally, Azure Content Understanding delivers multimodal content analysis, letting you extract data from forms, documents, images, videos, and audio streams. Integration and usage. To use Foundry tools, simply connect your client application to the relevant endpoint in your Microsoft Foundry resource, authenticate, and access the APIs or SDKs. Some tools even offer a user interface for configuration and testing within the Foundry portal.
Introduction to developing AI solutions with Microsoft Foundry. Developing AI solutions with Microsoft Foundry involves more than just using the portal. Developers need to write, test, and deploy code to bring their ideas to life. Let's explore how to make the most of the available tools. Choosing development tools and environments. Selecting the right development environment is key. If you're building Windows applications with the .NET framework, Microsoft Visual Studio is a strong choice. For web applications using open source languages, Visual Studio Code, or VS Code, offers flexibility and power. Streamlining workflow with the Foundry Toolkit extension. When working in VS Code, the Foundry Toolkit extension simplifies your workflow. You can browse and manage project resources, deploy models, and test agents in integrated playgrounds. Visual designers and YAML files help configure agents while integration code connects everything seamlessly. Leveraging GitHub and GitHub Copilot. GitHub is essential for source control and DevOps. Both Visual Studio and VS Code integrate natively with GitHub, giving you access to GitHub Copilot, an AI assistant that boosts productivity and effectiveness for developers. Programming languages, APIs, and SDKs. Microsoft Foundry supports languages like C#, Python, Node, TypeScript, and Java. Use the Microsoft Foundry SDK, OpenAI API, and Foundry Tools SDKs to connect, build, and deploy powerful AI solutions on Azure.
Artificial intelligence is transforming how we interact with technology, but with great power comes great responsibility. Let's explore Microsoft's core principles for building responsible AI systems that benefit everyone. Fairness. AI must treat all people fairly. For example, a loan approval model should not favor or disadvantage applicants based on gender, ethnicity, or other unrelated factors. Fairness starts with representative training data and continues with ongoing evaluation to ensure predictions remain unbiased for all user groups. Reliability and safety. AI systems must be reliable and safe. Imagine an autonomous vehicle or a medical diagnosis tool. Errors here can have serious consequences. Rigorous testing and careful management of prediction confidence are essential to protect users and ensure dependable outcomes. Privacy and security. AI relies on vast amounts of data, often containing sensitive information. Protecting privacy and securing data is crucial, both during model training and in production. Implement safeguards to keep customer data safe and maintain trust. Inclusiveness.
AI should empower everyone, regardless of ability, gender, or background. Involve diverse perspectives in design and testing to ensure your solution benefits all parts of society. Transparency. Users deserve to understand how AI works, its purpose, and its limitations. Clearly communicate how predictions are made and how personal data is used. Accountability. Ultimately, people are responsible for AI systems. Developers must ensure their solutions meet ethical and legal standards through strong governance and clear organizational principles.
Question 1. Which web portal should you use to work with assets in a Microsoft Foundry project? The Azure portal, Microsoft Copilot, the Microsoft Foundry portal.
Correct answer, C. Question 2. Which component of Microsoft Foundry provides pre-built services for common AI tasks? Foundry Tools, Foundry Models, Foundry IQ.
Correct answer?
A. Question 3. Which extension should you use in Visual Studio Code to work with Foundry projects? Python extension for Visual Studio Code, GitHub Copilot, Foundry Toolkit for Visual Studio Code. Correct answer, C. Select, deploy, and evaluate Microsoft Foundry models. Building effective generative artificial intelligence applications starts with one crucial decision: selecting the right foundation model for your specific use case. With thousands of models available, a structured approach is essential to ensure your application meets its goals. Choosing the right model. Imagine you are developing an artificial intelligence-powered customer support chatbot for a retail company. The model you choose must understand customer questions, provide accurate responses, and maintain a professional tone while ensuring safety standards. But with so many options, how do you find the best fit? Using the Microsoft Foundry portal streamlines this process. It offers access to over 1,900 models from leading providers like Microsoft, Anthropic, OpenAI, Meta, and Hugging Face. You can filter and compare models using industry-standard benchmarks for quality, safety, cost, and performance. Once you select a model, you can deploy it directly to an endpoint for your application and test it in a dedicated playground environment. Evaluating and improving performance. After deployment, evaluating your model's performance is key. The portal supports both automated metrics and manual testing, helping you ensure the model meets your quality and safety requirements. This structured workflow empowers you to build reliable, effective generative artificial intelligence applications.
The Foundry Models Catalog is your central hub for exploring and comparing artificial intelligence models. With over 1,900 models from various providers, it's designed to help you find the right model for your needs. How to find and filter models. The catalog's user interface in the Foundry portal makes searching simple. You can filter models by provider, capabilities, inference tasks, fine-tuning methods, industry, and more. Each model features a model card with key details like provider, benchmark metrics, and deployment options. Types of models in the catalog. You'll find two main categories: models sold directly by Azure, including Azure OpenAI and Microsoft models, and models from partners and the community, each with unique licensing and pricing. Models are organized into collections, such as those from Hugging Face or Azure. Specialized and domain-specific models. The catalog includes large language models for deep reasoning, small language models for efficiency, chat completion models, reasoning models, and specialized models for tasks like embedding, image generation, video creation, and speech processing. Some models are optimized for specific industries or languages. Summary and key takeaways. Whether you need a general-purpose model or one tailored for a specific domain, the Foundry Models catalog offers powerful tools and filters to help you discover, compare, and deploy the best artificial intelligence models for your project. Before choosing a model in Microsoft Foundry, it is essential to understand how it performs across several key areas. Model benchmarks provide the objective data you need to make informed decisions. Quality benchmarks. Quality benchmarks measure how accurately and coherently a model responds to different tasks. The Quality Index averages scores from datasets like Arena Hard for adversarial questions, Big Bench Hard for reasoning, and Human Eval Plus for code generation. Higher values mean stronger performance across language, reasoning, and coding tasks. Safety benchmarks. Safety benchmarks ensure models avoid generating harmful or biased content. Microsoft Foundry uses HarmBench to measure harmful behavior resistance, reporting attack success rate where lower is safer. Toxygen evaluates detection of hate speech, and WMDP checks knowledge in sensitive domains like biosecurity. These metrics are crucial for customer-facing applications.
Cost benchmarks help you balance quality with budget. Microsoft Foundry displays cost per million input and output tokens, plus an estimated cost using a typical 3-to-1 input to output ratio. Lower costs mean more budget-friendly models. Performance benchmarks. Performance metrics track how quickly models respond. Key measures include latency, time to first token, and throughput. Faster, high-throughput models improve user experience in real-time applications. Comparison tools. Use the leaderboard to compare models by quality, safety, cost, or throughput. Trade-off charts and side-by-side comparisons help you find the best fit for your needs. Deploying a machine learning model with Microsoft Foundry is straightforward. After selecting your model from the catalog, the Foundry portal guides you through deployment, making your model accessible through endpoints for your applications. Deployment types overview. Microsoft Foundry offers several deployment types, each tailored for different needs. Options include global standard for general workloads, data zone deployments for compliance, and batch deployments for large asynchronous jobs. The portal automatically selects the best type based on your model and environment, but you can review supported types before deploying. Deploying a model step by step. To deploy, navigate to your chosen model in the Foundry portal, review its specifications, and select Deploy. Choose default or custom settings, agree to any required terms, and configure deployment details like name, type, and compute resources. Once deployed, you'll land in the Foundry playground to test your model instantly. Managing and testing deployments. Manage your deployed models in the Build section. Here, you can view deployment status, access endpoint URLs, authentication keys, and monitor usage. The interactive playground lets you test prompts, adjust parameters, and experiment with system messages to refine model behavior. Programmatic access and integration. For integration, retrieve the endpoint URL, authentication key, and deployment name. Microsoft Foundry provides SDKs, REST API documentation, and code samples for languages like Python and JavaScript, making it easy to connect your applications to your deployed model. Evaluating your deployed model is essential for ensuring it delivers accurate, safe, and high-quality responses. Regular evaluation not only protects your users, but also helps your application continuously improve and meet compliance standards. Manual and automated evaluation. There are two main ways to evaluate your model: manual and automated. Manual evaluation involves human reviewers who test the model's responses for relevance, accuracy, and safety. This approach captures subjective qualities like user satisfaction and contextual appropriateness. Automated evaluation uses metrics such as groundedness, coherence, and fluency to objectively score responses. Risk and safety metrics help identify harmful or inappropriate content, while natural language processing metrics like F1 score and BLUE compare model outputs to reference answers for precision. Using the Microsoft Foundry portal streamlines evaluation. You can test models or agents using your own datasets, generate synthetic data, or use existing test cases. The portal supports running multiple metrics at once and provides a centralized evaluator library for managing and comparing evaluators, including custom ones. Interpreting results and next steps. After evaluation, review aggregate scores and detailed results. If scores are low, refine prompts, try different models, or add retrieval capabilities. Address safety concerns with content filters or prompt hardening. Regular evaluation ensures your model remains reliable and effective. Question 1. Which model benchmark indicates the model's ability to process prompts and return comprehensive responses quickly? Quality index? Cost? Throughput? Correct answer, C. Question 2. Which deployment type in Microsoft Foundry is best for general use while offering the largest quota? Data Zone Batch, Global Standard, Developer. Correct answer, B. Question 3. Which evaluation metric measures linguistic correctness and natural language quality? Fluency. Groundedness. Relevance. Correct answer? A. Develop a generative AI chat app with Microsoft Foundry. Developers using Microsoft Foundry have access to powerful tools for building generative AI chat applications on Azure. Key components. To get started, you need to select the right endpoint, software development kit, authentication method, and chat application programming interface options. These choices are essential for creating effective AI-powered chat experiences. Building the application. This module guides you through each step, helping you make informed decisions as you develop your generative AI chat app. Before you start coding your generative AI chat application, it is helpful to explore your project's possibilities using the Foundry portal. Foundry offers interactive tools that let you experiment, test, and generate code samples to kickstart your development. Exploring the Model Playground. The Model Playground in the Foundry portal is an interactive environment where you can test AI models before writing any code. Simply select Model Playground from the left navigation. Here, you can send prompts to deployed models, see responses in real time, adjust settings like temperature and maximum tokens, and add system messages to customize model behavior. This no-code environment helps you understand how different inputs and settings affect model responses. Generating code samples. A standout feature of the Model Playground is the Code button in the chat pane. At any point, you can select this button to generate code samples that reproduce your chat session. Choose your preferred API, programming language, and software development kit, or SDK. The samples are pre-filled with your project's endpoint, model deployment name, and current settings. From playground to application. The typical workflow is simple. Explore and test in the playground, generate code samples, develop your application using those samples, and iterate as needed. This approach helps you quickly prototype and refine your AI chat application. With Foundry, you can move seamlessly from experimentation to development, making it easier to build and improve your generative AI chat app. Microsoft Foundry offers developers flexibility for building generative AI chat applications. Before you start, it is important to understand your options for endpoints, software development kits, or SDKs, and authentication methods to make the right choices for your project. Endpoints and SDKs. Each Foundry project provides two endpoints, a project endpoint and an Azure OpenAI endpoint. Depending on your needs, you can use the Microsoft Foundry SDK or the OpenAI SDK. The Foundry SDK gives you access to project-level features, while the OpenAI SDK is ideal for model inference and compatibility with OpenAI's APIs. Authentication methods are crucial for secure access. Production applications should use Microsoft Entra ID authentication, which ties access to a specific identity. Alternatively, you can use key-based or token-based authentication, but always store keys securely and never hard-code them. When to use each SDK? Choose the Foundry SDK for features like agents, evaluations, and tracing. Use the OpenAI SDK for maximum compatibility with OpenAI APIs and portability between OpenAI and Azure OpenAI deployments. You can even combine both SDKs in one application. Microsoft Foundry empowers you to build flexible, secure, and scalable generative AI chat applications by choosing the right endpoints, SDKs, and authentication methods for your needs. The OpenAI Responses API unifies the capabilities of the Chat Completions and Assistance APIs, making it the recommended tool for conversational AI in Microsoft Foundry applications. It enables stateful, multi-turn conversations and works with both Azure OpenAI and Foundry Direct models. Key features. With the Responses API, you get a unified experience that maintains conversation context across multiple turns. It is simple to integrate using an OpenAI-compatible client, such as the Foundry SDK or OpenAI SDK. The API supports models hosted directly in Microsoft Foundry, like Microsoft Phi or DeepSeek. Generating responses. To generate a response, use the responses.create method with your chosen model and input prompt. You can also add instructions, known as system prompts, to guide the model's behavior for clear and concise answers. The response object includes output text, a unique identifier, status, usage, and model details. Conversation management. For multi-turn conversations, link responses using the previous _response ID parameter. This maintains context, allowing the model to build on earlier exchanges. Alternatively, you can manually manage conversation history for more control, such as customizing context or handling token limits. Advanced controls. Adjust parameters like temperature for creativity, max output tokens to limit length, and top P for randomness. These options help tailor responses to your application's needs. Streaming and async. For longer outputs, enable streaming to show responses incrementally. Asynchronous usage allows non-blocking API calls, ideal for responsive, high-performance chat applications. The OpenAI Chat Completions API is a widely used tool in generative artificial intelligence models and platforms. While the newer Responses API is recommended for new projects, Chat Completions remains important for code maintenance and ensuring compatibility across different systems. How to submit a prompt. To interact with the Chat Completions API, you submit a collection of message objects in JSON format. Each message includes a role, such as user or assistant, and the content of the message. This structure allows you to send prompts and receive responses from the model. Maintaining conversational context. Unlike the Responses API, the Chat Completions API does not automatically track conversation history. You need to manually keep a record of all previous prompts and responses. Each time you send a new prompt, you include the entire conversation history so the model can generate contextually relevant replies. Implementing a conversation loop. In real applications, conversations are often managed in a loop. Users enter prompts, and each new message is appended to the conversation history. The API then generates a response, which is also added, allowing for a seamless back-and-forth exchange. Why learn Chat Completions API? Although it lacks some advanced features, the Chat Completions API is well established and valuable to understand for anyone working with generative artificial intelligence models.
Question 1. Which endpoint offers the broadest support for OpenAI APIs with Foundry models? The Foundry Project endpoint, the Azure OpenAI endpoint, the Foundry Tools endpoint. Correct answer? B.
Question 2. Which package must you install to use the Microsoft Foundry SDK in Python? Package Azure Foundry. Package Azure AI Projects. Package Microsoft Foundry SDK.
Correct answer? B. Question 3. Which method do you use to generate responses with the Responses API? Client.chat.completions.create. Client.getResponseID. Client.responses.create. Correct answer, C.
Develop generative AI apps that use tools.
Generative artificial intelligence models are impressive at understanding and generating text, but they have a key limitation. They can only reason about information found in their training data. This means their knowledge is always a step behind the real world. Why tools matter. By integrating tools into your generative artificial intelligence interactions, you unlock a whole new level of capability. Tools bridge the gap between artificial intelligence reasoning and real-world actions. They allow your applications to fetch real-time information, like current weather or stock prices, and perform tasks such as sending emails or creating database records. Tools also help ground responses in facts, reducing errors and improving accuracy. Real-world applications. With tools, generative artificial intelligence can connect seamlessly to your existing systems, databases, and business logic. This extends its functionality and enables it to coordinate complex, multi-step processes. Without tools, artificial intelligence works in isolation. With them, it becomes an intelligent assistant that can observe, reason, and act on the world around it. Building intelligent assistants. Learning to specify tools and prompts is the first step toward building agentic artificial intelligence solutions. By managing tool configurations within your application, you create custom generative artificial intelligence-powered assistants tailored to your needs.
Microsoft Foundry models are advanced generative AI models designed to use tools for finding information or performing tasks. When building AI applications with Microsoft Foundry, you can search for models that support tool calling and deploy them to power your solutions. Tool calling capabilities. With tool calling capabilities, these models can access external resources or perform specific actions based on your prompts. By leveraging the OpenAI Responses Application Programming Interface, or API, you can specify which tools the model should use, making your AI applications more dynamic and responsive.
Commonly used tools. Some of the most popular tools available through the Responses API include the Code Interpreter, which provides a Python environment for generating and running code, Web Search, which allows the model to find up-to-date information online, File Search, which grounds responses in your uploaded files, and Function, which lets the model call custom functions in your application code. Specifying tools in the API. To use these tools, simply list them in your API call when generating a response. The model will choose when and how to use each tool, but you can guide its choices with system prompts and tool selection rules. Ongoing development and resources. Tool support is expanding rapidly. For more details, check the OpenAI Developer Guide.
The Code Interpreter tool is a powerful upgrade for generative AI models, giving them the ability to write and execute Python code in real time. This transforms the model from simply discussing ideas to actually performing calculations and data analysis.
Key features. With the Code Interpreter tool, models can dynamically run Python code in a secure, sandboxed environment. They can handle files like CSV, JSON, and images, perform on-the-fly data analysis, and even convert between data formats. The tool provides real-time feedback, allowing the model to see results, fix errors, and iterate quickly. It is especially useful for solving complex math problems, running simulations, and testing algorithms.
How it works. To use the Code Interpreter tool, include it in your Requests tools array. The model analyzes your task, generates the necessary Python code, and runs it using common libraries such as Pandas, NumPy, and Math. The results are then returned and incorporated into the model's response. Use cases. Common uses include parsing CSV files for summary statistics, solving physics equations, converting data formats, and prototyping new ideas before full implementation. Best practices and limitations. Be specific in your instructions, validate results, and monitor resource usage. Remember, code runs in a restricted environment with no external network access and some library limitations.
What is the Web Search tool? The Web Search tool allows a generative AI model to access current external information from the web while generating a response. Instead of relying only on its training data, the model can search the internet in real time to provide up-to-date answers. Key features and how it works. Key features include live information retrieval, source-grounded responses, and reduced hallucination risk. The model automatically decides when to search, issues queries, reviews relevant sources, and generates a response based on the latest web content. This seamless process ensures that users receive answers built on recent, reputable information, not just static knowledge. Use cases and best practices. The Web Search tool is especially useful for current events, market research, policy monitoring, and fact verification. For example, it can summarize breaking technology news, compare product pricing, or check for regulatory updates. To get the best results, ask clear, time-aware questions, request reputable sources, and seek concise summaries. For critical facts, always independently verify important claims. Limitations and final thoughts. Keep in mind, results depend on what is publicly available and may vary over time. Source quality can differ, and some environments may restrict web access. Used thoughtfully, Web Search transforms static AI into a timely, reliable assistant.
What is the File Search tool? The File Search tool lets AI models retrieve information directly from your own uploaded documents, such as policy manuals, contracts, or internal knowledge bases. This means answers are grounded in your trusted files, not just general training data, making responses more accurate and relevant. How does File Search work? To use File Search, you first upload your documents to a vector store, which organizes them for efficient searching. When you ask a question, the model searches these indexed files for relevant content, retrieves matching passages, and uses them to generate a grounded answer based on your documents. Key features and use cases. File Search offers semantic retrieval, finding information by meaning rather than just keywords. It integrates with vector stores, supports multiple document collections, and provides citations for transparency. Common use cases include answering HR policy questions, retrieving troubleshooting steps, reviewing legal clauses, and summarizing technical documentation. Best practices and limitations. For best results, use clean, up-to-date documents and ask focused questions. Keep vector stores organized by domain, like HR or legal, to improve accuracy. Remember, answer quality depends on your source files, and human review is still important for sensitive decisions. File Search transforms general AI into a domain-aware assistant.
The Function tool lets your AI model connect with real-world systems by calling developer-defined functions. Instead of running your business logic directly, the model requests a function call, your code executes it, and then the result is sent back to the model for a grounded response. How the Function tool works. Here's how it works. First, you define one or more functions in your application. When a user prompt comes in, the model decides if a function call is needed. If so, it emits a structured request with the function name and details. Your application runs the function, returns the output, and the model uses that result to complete its answer. This pattern is ideal for integrating with APIs, databases, or automating workflows. Example in action. For example, if you expose a getTime function, the model can call it when a user asks, "What time is it?" Your code runs getTime, returns the current time, and the model responds with the answer. This keeps responses accurate and up to date. Best practices and limitations. Keep functions focused, validate inputs, and handle errors clearly. Remember, your app runs the functions, not the model. Used well, the Function tool transforms your model into a reliable orchestrator for real-world tasks.
Question 1. Which tool should you use when a model needs to answer questions from your own uploaded policy documents? Web Search, File Search, Code Interpreter?
Correct answer? B.
Question 2. In a function calling workflow, what should your application do after the model returns a function call item? Wait for the model to run the function automatically? Run the function in your code and send a function call underscore output back to the model. Convert the function call into a web search request? Correct answer, B. Question 3. Which statement about the code interpreter tool is correct? It can run Python code in a sandboxed runtime to help solve tasks. It can browse external websites directly during code execution. It only supports file uploads and can't perform calculations. Correct answer, A. Optimize generative AI model performance with Microsoft Foundry. Language models are at the heart of generative AI applications, powering everything from chatbots to content creation tools. However, a base model alone may not deliver the quality, accuracy, or consistency you need for your specific use case. Optimizing these models is essential for achieving the best results. Developer scenario. Consider a developer at a travel agency tasked with building a chat application to assist customers. While the base language model provides decent answers, the team needs more. They want responses that match the company's tone of voice, include up-to-date details from their hotel catalog, and maintain a consistent format in every interaction. Strategies for optimization. To meet these requirements, developers can use several complementary strategies. Some are quick and low cost, like adjusting prompts or fine-tuning response formats. Others are more involved, such as integrating company-specific data or retraining the model with custom examples. Each approach helps tailor the model's output to better fit business needs, ensuring accuracy and consistency in every customer interaction. Applying strategies effectively. Throughout this process, it's important to learn when and how to apply each strategy, either individually or in combination, to optimize generative AI models for your unique application requirements. Optimizing a language model's performance often starts with prompt engineering. This means carefully designing and refining the questions or instructions you give the model. It is accessible, requires no extra infrastructure, and lets you experiment instantly to improve response quality and relevance. Key components of a prompt. A prompt typically includes several parts: system instructions that set the model's role and boundaries, the user's question, previous assistant responses for context, and examples that show the desired format. How you combine these elements directly shapes the model's output. Designing effective system messages. System messages guide the model's behavior. For example, you might say, "You are a friendly travel advisor for Margie's Travel. Answer only travel-related questions." These messages set tone, format, and boundaries, but you should test and iterate for best results. Prompt patterns and examples. Use patterns like the persona pattern to set a specific role, format templates for structured outputs, and chain of thought prompts to encourage step-by-step reasoning. Few-shot learning, where you provide examples, helps the model learn your desired response style. Model parameters and practical tips. Adjust parameters like temperature for creativity or top P for response focus. Use clear delimiters to separate instructions and content. Remember, prompt engineering is powerful, but if the model lacks needed information, further strategies may be required. Retrieval Augmented Generation, or RAG, is a technique that helps language models provide more accurate answers by grounding their responses in real, up-to-date data. This is especially important when the model's training data is outdated or missing private information. Why grounding matters. Without grounding, a language model can only rely on its original training data. This means it might generate responses that sound correct, but are actually inaccurate or even fabricated. For example, it could invent hotel names when asked about available hotels in Paris. How RAG works. RAG follows 3 steps: retrieve, augment, and generate. First, it searches a data source for information relevant to the user's question. Next, it adds this information to the prompt. Finally, the model generates a response based on the combined context, ensuring factual accuracy. Embeddings and search. A key part of RAG is using embeddings, which are mathematical representations of text. These help the system find semantically similar information, even if the wording is different. Azure AI Search combines keyword, semantic, and vector search for the best results. When to use RAG. RAG is ideal when you need domain-specific knowledge, frequently updated information, or high factual accuracy. It's especially useful when your data changes often, or when the model's training data has a cutoff date. Fine-tuning is a way to customize a pre-trained language model like GPT-4o so it consistently matches your specific style, tone, or output format. When prompt engineering and retrieval augmented generation are not enough, fine-tuning helps bridge the gap. How fine-tuning works. Fine-tuning uses a technique called low-rank adaptation, or LoRa, which updates only a small subset of the model's parameters. This makes training faster and more cost-effective, while still allowing the model to learn from your task-specific examples. When to fine-tune? Fine-tuning is ideal when you need consistent brand voice, structured outputs, or want to reduce prompt length. For example, a travel agency can ensure every response uses a warm, encouraging tone and follows strict formatting without relying on long prompts. Types of fine-tuning. There are several techniques. Supervised fine-tuning uses labeled prompt and response pairs, reinforcement fine-tuning optimizes through feedback, and direct preference optimization, or DPO, aligns the model with human preferences efficiently. Preparing data and challenges. You'll need high-quality representative examples in JSON lines format with consistent system messages. Fine-tuning introduces costs, requires careful data preparation, and ongoing maintenance to avoid issues like overfitting or model drift. Always evaluate baseline performance first. When optimizing artificial intelligence models, three main strategies work together: prompt engineering, retrieval augmented generation, or RAG, and fine-tuning. Each addresses different needs, and combining them can unlock the best results for your application. The optimization spectrum. Prompt engineering shapes how the model behaves by providing clear instructions and examples. RAG brings in up-to-date domain-specific knowledge by retrieving relevant data at query time. Fine-tuning, meanwhile, trains the model on specific examples to ensure consistent style, tone, or format. These strategies are not mutually exclusive. They complement each other across the optimization spectrum. Trade-offs and combinations. Prompt engineering is fast and cost-effective, but limited by the model's original training data. RAG improves factual accuracy but requires search infrastructure and careful data indexing. Fine-tuning delivers the most consistent behavior but involves significant upfront investment. Often, the most effective solutions combine these strategies. For example, prompt engineering plus RAG defines both how the model should act and what it needs to know, while fine-tuning plus RAG ensures both style consistency and factual accuracy. Decision framework. Start simple. Use prompt engineering first. If you need more accuracy, add RAG. For greater consistency, layer in fine-tuning. Combine strategies as needed based on your application's requirements. Question 1. What is the primary purpose of a system message in a prompt? To define the model's role, behavior, and output constraints. To provide training data that permanently changes the model. To retrieve data from an external data source. Correct answer? A. Question 2. When should you use retrieval augmented generation, RAG, instead of relying on prompt engineering alone? When you want the model to respond in a consistent style and format, when the model needs access to domain-specific or current data that it wasn't trained on, when you want to reduce the length of prompts sent to the model. Correct answer? B. Question 3. What does the temperature parameter control in a language model? The maximum number of tokens the model can generate, the randomness and creativity of the model's responses, the speed at which the model processes requests. Correct answer? B. Question 4. What does fine-tuning optimize in a language model? The factual accuracy of responses by connecting to external data. The consistency of the model's behavior, style, and output format. The number of tokens the model can process in a single request. Correct answer? B. Question 5. You're building a chat application that needs to answer questions using your company's product catalog while maintaining a specific brand voice. Which combination of strategies is most appropriate? Prompt engineering only with detailed system messages? RAG for the product catalog data, fine-tuning for the brand voice, and prompt engineering for conversation-specific instructions. Fine-tuning only with the product catalog included in the training data. Correct answer? B. Implement a responsible generative AI solution in Microsoft Foundry. Generative artificial intelligence, or AI, is transforming technology by enabling developers to create applications that use machine learning models trained on vast amounts of data from across the internet. These models can generate new content that often appears indistinguishable from what a human might create. Risks and the need for responsibility. With such powerful capabilities, generative AI introduces significant risks. Data scientists, developers, and everyone involved in building generative AI solutions must take a responsible approach. This means actively identifying, measuring, and mitigating potential dangers associated with these technologies. Microsoft's Responsible Generative AI Guidelines. Experts at Microsoft have developed a set of guidelines for responsible generative AI. These guidelines build on Microsoft's responsible AI standard, addressing unique considerations for generative AI models. Following these principles helps ensure that generative AI is developed and used in a safe, ethical, and trustworthy manner. Microsoft's guidance for responsible generative artificial intelligence, or AI, is designed to be both practical and actionable. It provides a clear roadmap for organizations looking to use generative models responsibly. The 4-stage process. The guidance outlines a 4-stage process. First, map potential harms that could arise from your planned solution. Next, measure the presence of these harms in the outputs generated. Then, mitigate these harms at multiple layers to minimize their impact while ensuring transparent communication about risks to users for users. Finally, manage the solution responsibly by defining and following a deployment and operational readiness plan. Aligning with industry standards. These 4 stages closely correspond to the functions in the National Institute of Standards and Technology, or NIST, AI Risk Management Framework, ensuring alignment with recognized industry standards. Practical implementation. Microsoft's approach offers actionable suggestions for each stage, helping organizations implement successful and responsible generative AI solutions. By following this guidance, teams can address risks proactively and build trust in their AI systems. Mapping potential harms is the essential first step in building responsible generative artificial intelligence solutions. By systematically identifying, prioritizing, testing, and documenting risks, teams can create safer and more trustworthy AI systems. Identifying potential harms. Start by identifying possible harms your generative AI solution could cause. These might include generating offensive or discriminatory content, spreading factual inaccuracies, or encouraging illegal or unethical behavior. Review documentation from model providers, like the transparency notes for Azure OpenAI Service or the OpenAI system card for GPT-4, to understand known limitations. Use resources such as the Microsoft Responsible AI Impact Assessment Guide to help uncover and document these risks. Prioritizing harms. Next, assess each identified harm for its likelihood and potential impact. For example, a smart kitchen co-pilot might risk suggesting undercooked recipes, or more seriously, providing instructions for dangerous substances. Prioritization should consider both the intended use and potential misuse, often requiring input from policy or legal experts. Testing and verification. With a prioritized list, test your solution to verify if these harms can actually occur. Red team testing, where experts deliberately probe for weaknesses, is a proven strategy to uncover vulnerabilities and harmful outputs in generative AI systems. Documenting and sharing. Finally, document all verified harms and share them with stakeholders. Maintain and update this list as new risks are discovered, ensuring ongoing responsible AI development. To ensure artificial intelligence systems are safe and responsible, it is crucial to measure potential harms they might produce. Establishing a baseline helps teams understand the current risks and track improvements as they refine their solutions. Step 1. Preparing prompts. Begin by compiling a diverse set of input prompts designed to trigger each documented potential harm. For instance, if a risk involves the system providing dangerous instructions, create prompts that could elicit such responses. This ensures testing covers all identified concerns. Step 2. Testing and output collection. Next, submit these prompts to the artificial intelligence system and collect the generated outputs. This step provides real examples of how the system responds to risky scenarios, forming the basis for further evaluation. Step 3. Evaluating and categorizing harm. Apply strict, predefined criteria to assess each output. Categorize the results by their level of potential harm, whether simply harmful or not harmful, or using a more detailed scale. Consistent criteria are essential for reliable measurement. Manual and automated testing. Start with manual testing to ensure your evaluation criteria work as intended. Then automate testing with larger data sets, possibly using classification models. Periodically return to manual checks to validate new scenarios and automated results. Tracking and sharing results. Document your findings and share them with stakeholders, supporting transparency and ongoing improvement in artificial intelligence safety. Mitigating harm in generative artificial intelligence solutions requires a thoughtful, layered approach. After establishing a baseline for harmful outputs and measuring them, you can apply targeted strategies to reduce risks, then retest and compare results to ensure improvement. Model layer. At the core is the model layer. Choosing the right model for your use case is crucial. For instance, a simpler model may be safer for classifying short texts than a powerful model like GPT-4. Fine-tuning foundational models with your own data can also help ensure outputs are relevant and less likely to cause harm. Safety system layer. Next is the safety system layer. Here, platform-level tools like Microsoft Foundry's guardrails come into play. These guardrails use content filters to classify and suppress harmful content across categories such as hate, violence, and self-harm. Prompt shields can detect and prevent systematic abuse of the system. System message and grounding layer focuses on how prompts are constructed. By defining behavioral parameters and using prompt engineering, you can guide the model towards safer outputs. Retrieval Augmented Generation, or RAG, adds trusted context to prompts, further reducing risk. User Experience Layer. Finally, the user experience layer shapes how users interact with the system. Constraining input types and validating outputs can prevent harmful responses. Transparent documentation about system capabilities and limitations helps users understand any remaining risks, supporting responsible use. Pre-release reviews. Before launching a generative artificial intelligence solution, it is essential to complete thorough pre-release reviews. Identify all compliance requirements relevant to your organization and industry. Make sure legal, privacy, security, and accessibility teams have the opportunity to review both the system and its documentation. This step helps ensure your solution meets all necessary standards and regulations. Release planning. A successful release depends on careful planning. Start with a phased delivery plan, releasing your solution to a restricted group of users first. This approach allows you to gather feedback and address any issues before a wider rollout. Prepare an incident response plan that estimates response times for unexpected incidents, and develop a rollback plan to revert to a previous state if needed. Operational safeguards. Implement safeguards to protect your system and users. Ensure you can immediately block harmful responses if they are discovered. Set up the ability to block specific users, applications, or client internet protocol addresses in case of misuse. These measures help maintain the integrity and safety of your solution. Feedback and monitoring. Enable users to provide feedback and report issues, especially for content that is inaccurate, incomplete, harmful, or offensive. Track telemetry data to monitor user satisfaction and identify usability challenges, always complying with privacy laws and your organization's privacy commitments. Question 1. Why should you consider creating an AI impact assessment when designing a generative AI solution? To make a legal case that indemnifies you from responsibility for harms caused by the solution? To document the purpose, expected use, and potential harms for the solution? To evaluate the cost of cloud services required to implement your solution? Correct answer? B. Question 2. What capability of Microsoft Foundry helps mitigate harmful content generation at the safety system level? DALL-E model support? Fine-tuning? Guardrails? Correct answer, C. Question 3. Why should you consider a phased delivery plan for your generative AI solution? To enable you to gather feedback and identify issues before releasing the solution more broadly? To eliminate the need to map, measure, mitigate, and manage potential harms? To enable you to charge more for the solution? Correct answer? A. Part 2. Develop AI agents on Azure. Part 2. Develop AI agents with Microsoft Foundry and Visual Studio Code. Healthcare organizations often need to automate patient interactions while keeping data secure and significant coding, making security and scalability challenging. What is Microsoft Foundry Agent Service? Microsoft Foundry Agent Service is a fully managed platform designed to simplify the creation and deployment of AI agents. With this service, you do not need to manage underlying compute or storage resources. It offers enterprise-grade security, making it ideal for sensitive environments like healthcare. You can work through the Foundry portal or directly in Visual Studio Code, giving you flexibility in your development workflow. An AI agent is a software service powered by generative artificial intelligence, or AI, that can understand context, make decisions, and perform tasks independently. Unlike traditional apps, AI agents adapt to new scenarios and act on your behalf to achieve specific goals. Why AI agents matter? AI agents automate repetitive tasks, freeing people to focus on creative work. They process vast amounts of data, analyze trends, and provide real-time recommendations, supporting smarter decision-making. With the ability to scale operations and work around the clock, AI agents boost productivity and efficiency for organizations of all sizes. Real-world applications. AI agents are transforming industries. Personal productivity agents help schedule meetings and manage emails. Research agents track trends and generate reports. Sales agents automate lead generation, while customer service agents resolve inquiries instantly. Developer agents like GitHub Copilot assist with code review and bug fixing. Security considerations. As AI agents become more autonomous, security is crucial. Risks include data leakage, prompt injection attacks, unauthorized access, and data poisoning. Organizations must enforce role-based access controls, validate prompts, and maintain detailed logging to deploy AI agents safely. Microsoft Foundry Agent Service. Microsoft Foundry Agent Service lets developers securely build, deploy, and scale AI agents with minimal code. It offers automatic tool integration, secure data management, model selection, and enterprise-grade security, making intelligent automation accessible and safe for businesses.
Microsoft Foundry Agent Service gives you flexible options for building AI agents, whether you prefer visual tools or code-driven workflows. Let's explore how you can choose the right approach for your team. Foundry Portal Overview. The Foundry Portal offers a web-based interface for creating and managing AI agents without writing code. It is perfect for quick prototyping, collaborating with non-technical stakeholders, and managing agents in one centralized place. You can visually configure agents, monitor resources, and share configurations easily. For developers who prefer working in code, the Microsoft Foundry extension for Visual Studio Code brings enterprise-grade AI capabilities directly into your development environment. You can manage resources, test agents, edit YAML configurations, and deploy containerized agents all within your familiar code editor. Typical workflow and Azure resources. No matter which approach you choose, the workflow is consistent. Connect to your Foundry project, create and configure agents, test and iterate, then deploy and integrate. Both methods require a Microsoft Foundry project and deployed AI models, with optional Azure services like Azure AI Search or Azure Storage for advanced capabilities. Choosing your approach. Choose the Foundry portal for visual configuration and centralized management, or Visual Studio Code for developer-centric, version-controlled workflows. Many teams use both, switching as needed for flexibility and efficiency. Building your first AI agent in the Microsoft Foundry portal is designed to be approachable, even if you have no coding experience. The portal's visual interface guides you step by step, making agent development accessible and easy to understand. Creating and configuring your agent. To get started, sign in at ai.azure.com with your Azure credentials. Choose your project or create a new one, then navigate to Build and select Agents. Click Create to begin. You'll enter a name, a clear description of your agent's purpose, and select or deploy a model. Once created, the configuration interface lets you define your agent's instructions, which shape how it responds and handles scenarios. You can also adjust model parameters like temperature for response randomness and top P for response diversity. Testing and enhancing your agent. The integrated playground allows you to test your agent in real time. Start a conversation, validate instructions, and see how your agent maintains context across multiple turns. Enhance your agent by adding tools from the catalog, such as Code Interpreter, Bing Web Search, or your own custom tools. Deploying and integrating your agent. When you're satisfied, deploy your agent for production. The portal provides deployment status and connection details, making it easy to integrate your agent into applications using the Microsoft Foundry Software Development Kit or REST APIs. Setting up Visual Studio Code for AI agent development brings enterprise-grade tools right into your favorite editor. With the Microsoft Foundry extension, you can build, test, and deploy AI agents without ever leaving Visual Studio Code. Installing the Microsoft Foundry extension. To get started, open Visual Studio Code and head to the Extensions panel. Search for Foundry in the Marketplace, then select and install the Microsoft Foundry extension. Once installed, you'll see the Foundry icon in your activity bar, giving you quick access to all its features. Connecting to Azure and preparing for agent development. Next, connect the extension to your Azure account. Sign in, expand your Azure subscription, and open your Microsoft Foundry project. Before building agents, make sure you have an AI model deployed. In the Resources section, create a new model deployment, choose your model, configure its settings, and deploy. Managing agents in Visual Studio Code. Agents created in the Foundry portal appear automatically in the extension. You can browse, switch between, duplicate, or archive agents, and compare configurations side by side, all within Visual Studio Code. Benefits of the integrated workflow. With Microsoft Foundry, you gain a seamless, powerful environment for rapid agent development, iteration, and deployment, all from within Visual Studio Code.
Configuring declarative agents in Microsoft Foundry is all about tailoring your agent's behavior to your needs. Whether you use the agent designer or edit YAML files directly, you have flexible options for setup. Core agent configuration. Start by naming your agent clearly so its purpose is obvious to your team. Add a concise description to help others understand what your agent does at a glance. Select the AI model you want to power your agent's responses from the drop-down of deployed models. Define system instructions to shape your agent's personality, behavior, and response style. Each agent also gets a unique agent ID, automatically generated for API calls.
Fine-tune your agent's responses by adjusting parameters like temperature, which controls creativity, and top P, which manages vocabulary diversity. For business tasks, a temperature between 0.3 and 0.7 is usually best. YAML structure and benefits. The YAML file organizes everything: metadata, model configuration, instructions, and tools. Editing YAML directly enables version control, bulk updates, reusable templates, and automation. The extension even validates your YAML in real time. Best practices. Commit YAML files to Git, use descriptive names and tags, document complex instructions, and test after every change. Start simple, then iterate for reliable, focused agents.
AI agents in Microsoft Foundry are more than just chatbots. Their real power comes from using tools that let them perform actions, access data, and connect with external systems, transforming simple conversations into advanced automation. How tools work in Microsoft Foundry. Tools in Foundry are programmatic functions agents can call automatically. When you ask an agent for something complex, it decides which tool to use, runs it, and blends the results into its response. This seamless process lets agents handle real-time data, code execution, and more. Key built-in tools. Foundry's tool catalog includes ready-to-use options like Code Interpreter for running Python code, File Search for searching your documents, Bing Web Search for live internet results, and Azure AI Search for enterprise data. You can add these tools visually or by editing the YAML configuration. Custom integrations and MCP servers. For advanced needs, Foundry supports custom tools via OpenAPI specifications and Model Context Protocol, or MCP, servers. MCP servers standardize tool integration, making it easy to reuse and share tools across projects, whether hosted remotely or developed locally. Start with built-in tools, match them to your agent's needs, and keep your knowledge bases updated. By combining tools and custom integrations, you unlock powerful, reliable automation with Microsoft Foundry.
Before releasing your agent, thorough testing is essential. Microsoft Foundry offers playgrounds in both the portal and Visual Studio Code extension for interactive testing. Test the happy path, edge cases, boundaries, multi-turn conversations, and tool invocations. Record your results to track improvements and catch regressions. Deploying agents. Once testing is complete, deploy your agent to your Foundry project. In the Foundry portal, verify your configuration and select Save. In Visual Studio Code, use Save to Foundry or Deploy to Microsoft Foundry for hosted agents. Deployment keeps your agent accessible for further team testing and iteration. Publishing agents. Ready to go live? Publishing creates an agent application in Azure, making your agent callable through a stable endpoint. Use the Foundry portal or Visual Studio Code to publish. This step moves your agent from your project workspace to a managed Azure resource, enabling external access.
Endpoint and authentication. Published agents expose a consistent endpoint URL using the Responses API protocol. Authentication is handled by Microsoft Entra ID. Assign the Azure AI user role to callers. Remember, permissions do not transfer automatically, so reassign roles to the new agent identity after publishing. Production tips. Monitor performance, secure access, and manage costs. Use application insights for tracking. Apply least privilege access and set response limits. Store conversation history client-side for multi-turn interactions. And implement robust error handling for a reliable production experience.
Question 1. What is the primary benefit of using Microsoft Foundry Agent Service compared to building agents with standard APIs? It provides access to more powerful AI models. It requires no Azure subscription. It handles tool calling, state management, and infrastructure automatically. It only works with the Azure portal.
Correct answer, C.
Question 2. How does Microsoft Foundry Agent Service handle conversation state? By requiring developers to manually manage conversation history, through external database connections, through the Responses API, which automatically manages conversation context, using local file storage on the client device.
Correct answer, C. Question 3. Which of the following is not a recommended security practice for AI agents? Using role-based access controls, implementing prompt filtering and validation, maintaining comprehensive logging and traceability, allowing agents unrestricted access to all enterprise data.
Correct answer, D.
Question 4. What happens when an agent determines it needs a tool to respond to a user request? The agent asks the user for permission to use the tool. The agent stops processing and waits for developer input. The agent automatically invokes the tool, processes results, and incorporates them into its response. The agent sends the request to a separate processing queue.
Correct answer, C. Integrate custom tools into your agent. Microsoft Foundry Agent Service makes building an AI agent accessible, even if you do not have deep expertise in artificial intelligence or machine learning. With this service, you can quickly create agents that perform tasks and automate actions on your behalf. Built-in and custom tools. The AI agent service comes with built-in tools for gathering knowledge and generating code, giving your agent powerful capabilities right out of the box. However, sometimes your agent needs to handle tasks that go beyond what an AI model can do alone. In these cases, you can provide your agent with a custom tool, which could be your own code or a third-party service or application programming interface, also known as an API. Retail industry example. Consider a retail company facing challenges with customer inquiries. The support team is overwhelmed by repetitive questions, causing delays and lower customer satisfaction. By using Foundry Agent Service and adding custom tools, you can build a custom frequently asked questions agent. This agent can look up customer orders, allowing your team to focus on more complex support issues. Benefits and learning outcomes. With custom tools in Foundry Agent Service, you can boost productivity, improve accuracy, and create solutions tailored to your organization's unique needs. This module will guide you through using custom tools to enhance your agent's capabilities. Microsoft Foundry Agent Service is a platform designed to help businesses boost productivity by integrating custom tools. These tools allow organizations to create tailored solutions that address their unique operational needs, making work more efficient and effective. Why custom tools matter? Custom tools are essential because they automate repetitive tasks and streamline workflows specific to each business. By providing precise and consistent outputs, these tools reduce human error and improve accuracy. Most importantly, they offer solutions tailored to your organization's challenges, helping you optimize processes and achieve better results. How custom tools work. When a user interacts with an agent, the agent can access custom tools to respond intelligently. For example, if someone asks about weather conditions at a ski resort, the agent can use a tool that retrieves real-time meteorological data, then share the report with the user. This flexibility allows agents to deliver relevant, up-to-date information. Real-world examples. Custom tools in Foundry Agent Service are used across industries. Retailers automate customer support by connecting agents to customer relationship management systems. Manufacturers streamline inventory management. Healthcare providers simplify appointment scheduling. IT departments resolve technical issues faster. And educational institutions enhance e-learning experiences, all through tailored agent integrations. With Microsoft Foundry Agent Service, custom tools empower organizations to solve unique challenges, drive efficiency, and deliver real value. Microsoft Foundry Agent Service empowers your AI agents with a suite of custom tools designed to boost efficiency and interoperability. These tools make it easy to connect with existing infrastructure and web services, supporting scalable integration across diverse applications. Custom function calling. One standout feature is function calling. This allows you to describe the structure of custom functions to your agent, enabling it to dynamically identify and call the right functions with the correct arguments. It is ideal for integrating custom logic and workflows, supporting a variety of programming languages for maximum flexibility. Azure Functions and event-driven apps are another powerful option. They let you build intelligent, event-driven applications with minimal overhead. With triggers and bindings, your AI agents can easily interact with external systems and services, streamlining connections to both input and output data sources. Open API specification tools enable your Azure AI agent to connect with external APIs using the Open API 3.0 standard. This ensures automated, scalable, and standardized API integrations, making it easier to generate client code, create tests, and apply design standards. Azure Logic apps offer low-code or no-code solutions for building workflows. This flexibility allows you to connect apps, data, and services, unlocking extensive extensibility for your Foundry Agent Service agents. Custom tools let agents do more than just chat. With the right setup, agents can fetch data, process requests, and interact with external systems, all on their own. Function calling.
Function calling allows agents to execute predefined functions based on user input. For example, you can define a function to track snowfall in different cities. Once registered, the agent decides when to call this function, like fetching recent snowfall totals for Seattle or Denver, without you writing extra code for each scenario. Azure Functions. Azure Functions offer serverless computing for real-time processing. By integrating an Azure function, your agent can respond to triggers such as HTTP requests or queue messages. For instance, an agent can use an Azure function to get weather information for a location, sending requests through a storage queue and processing the results automatically. Open API specification. Open API tools let agents interact with external APIs using standardized specifications. By registering an Open API specification, your agent can fetch weather data or other information from public APIs. The Foundry Agent Service supports Open API 3.0, making integration with various services straightforward and secure. With function calling, Azure Functions, and Open API, agents become powerful, flexible, and intelligent, enabling seamless integration with external systems and scalable custom solutions.
Question 1. What are custom tools and how can they help you develop effective agents with Microsoft Foundry Agent Service? Correct answer? A. Question 2. You need to integrate functionality from an Open API 3.0 based web service into an agent solution. What should you do? Add the JSON schema of the web service to the agent's instructions. Rewrite the web service as a Python function and hard-code it in your agent app. Add the web service as an Open API specification tool to the agent definition.
Correct answer, C. Question 3. Your agent application code includes a local function that you want the agent to call. What kind of tool should you add to the agent's definition? Function calling? Code interpreter? Azure Functions?
Correct answer? A.
Integrate MCP tools with Azure AI agents. AI agents are becoming increasingly powerful, but many tasks still require them to interact with external tools. Whether it is accessing APIs, databases, or internal company services, integrating these resources can quickly become complicated as your system evolves or expands. What is Model Context Protocol, or MCP? The Model Context Protocol, or MCP, offers a solution to this challenge. By connecting an AI agent to an MCP server, you provide the agent with a dynamic catalog of tools that can be accessed on demand. This makes your AI solution more robust, scalable, and easier to maintain as your needs change. Real-world example: cosmetics retailer. Imagine you work for a cosmetics retailer. Your team wants to build an AI assistant to help manage inventory by checking product stock levels and analyzing recent sales trends. With an MCP server, your assistant can connect to specialized tools that assess inventory and offer actionable recommendations to your team. Getting started with MCP and Azure AI agents. In this module, you will learn how to set up both an MCP server and client, connect tools to an Azure AI agent dynamically, and even create your own AI MCP tool solution using Microsoft Foundry Agent Service. As artificial intelligence agents become more advanced, the number of tools and services they can access is rapidly expanding. But managing, updating, and integrating these tools can quickly become overwhelming. That is where dynamic tool discovery comes in, allowing agents to automatically find and use tools at runtime. How the Model Context Protocol works. The Model Context Protocol, or MCP, is a solution designed to streamline this process. Instead of manually coding each integration, MCP enables agents to query a centralized server for a live catalog of available tools. These tools are exposed by the server and described so agents can understand and use them instantly. Benefits of MCP for AI agents. With MCP, developers only need to integrate once, reducing maintenance and improving adaptability. MCP also works across different large language models, or LLMs, so switching models does not require reworking integrations. Standardized security means agents can securely access multiple servers without juggling separate authentication keys. Why dynamic tool discovery matters. Dynamic tool discovery with MCP makes AI agents more scalable, modular, and maintainable. Tools can be added or updated centrally, letting agents always use the latest versions. This flexibility is crucial in fast-changing environments, helping agents adapt and interact with external systems in real time.
To integrate tools with your Azure AI agent, you need the Model Context Protocol, or MCP. MCP provides a dynamic way to connect, manage, and update tools without hard coding them into your agent's logic. Setting up the MCP server. Start by setting up an MCP server, which acts as a registry for your tools. Using fast MCP, you can easily define tools with Python type hints and doc strings. These tool definitions are served over HTTP, so you can update or add tools anytime without redeploying your agent. Connecting with the MCP client. Next, the MCP client bridges your server and the Azure AI Agent service. It initializes a session, discovers available tools using session.listtools, and generates Python function stubs that wrap each tool. This makes every tool in your catalog accessible to your agent. Registering tools with Azure AI Agent. Each tool is wrapped in an asynchronous function, then bundled into a function tool. Register these with your agent's toolset. Now, your agent can invoke any tool from the MCP catalog using natural language, all at runtime. Benefits of MCP integration. With MCP, you separate tool management from agent logic. This means your system can quickly adapt as new tools become available, keeping your Azure AI agent flexible and up to date. You can take your Microsoft Foundry agent to the next level by connecting it to Model Context Protocol servers, or MCP servers. These servers provide powerful tools and contextual data, expanding your agent's abilities far beyond its built-in functions. Connecting your agent. With Azure AI Agent Service, integrating remote MCP servers is seamless. You do not need to manually create client sessions or add function tools. Instead, you simply create an MCP tool object that connects directly to your chosen MCP server. When you invoke a prompt, just add the server information to the agent thread and your agent can access tools from one or even multiple servers as needed. Configuring MCP tools. To connect, you need a remote MCP server endpoint and a Microsoft Foundry agent set up to use the MCP tool. Each MCP tool can be customized with a unique server label, the server's URL, and optional parameters like allowed tools or approval requirements. You can also add custom headers for authentication, such as API keys or OAuth tokens. Invoking tools and approvals. Once configured, MCP tools are automatically invoked during agent runs. If approval is required, you'll receive an approval request and can respond with your decision, ensuring secure and controlled tool usage. The future of MCP integration. As the MCP ecosystem grows, your agents will become even smarter and more dynamic, unlocking new possibilities for your workflows. Question 1. What role does the MCP server play in the MCP agent tool integration? Runs the AI agent and processes user prompts directly? Manages network connections between multiple agents? Hosts tool definitions and makes them available for discovery by the client? Correct answer, C. Question 2. How does an MCP client retrieve available tools from the MCP server? By calling session.listtools to get the current tool catalog. By reading a static JSON file from the server directory. By subscribing to server events via a WebSocket connection. Correct answer? A. Question 3. Why should MCP tools be wrapped in async functions on the client side? To allow the agent to wait for user input? To enable asynchronous invocation so the agent can call tools without blocking? To convert the functions into REST API endpoints automatically? Correct answer? B. Build knowledge-enhanced AI agents with Foundry IQ. Organizations are turning to AI agents to automate tasks and increase productivity. But scaling these agents beyond basic, predefined tasks presents a major challenge. The question is, how can you empower AI agents to handle complex, context-rich work that truly drives value? The power of knowledge-enabled agents. The answer lies in giving agents access to your organization's knowledge. This includes policies, procedures, product documentation, support articles, and years of domain expertise. When agents can tap into this information, they move beyond generic responses and deliver insights tailored to your company's unique context. Engineering hurdles and traditional limitations. Traditional AI agents face big limits. They cannot access private data, are restricted by knowledge cutoff dates, and often generate inaccurate information.
Building knowledge-enabled agents means tackling complex engineering tasks like connecting to data sources, managing access controls, and building vector databases, challenges that every team faces repeatedly. Foundry IQ, the unified solution. Foundry IQ, Microsoft's unified knowledge platform, changes the game. Instead of building custom retrieval augmented generation, or RAG, pipelines for every project, you get a shared system. Multiple agents can access the same knowledge bases, and improvements benefit all agents instantly. Key capabilities and next steps. With Foundry IQ, you can configure data sources, control retrieval behavior, and monitor agent performance. This unified approach transforms simple agents into powerful, knowledge-enhanced assistants ready for real-world impact. Engineering hurdles and traditional limitations. Traditional AI agents face big limitations. They cannot access private data, are restricted by knowledge cutoff dates, and often generate inaccurate information. Building knowledge-enabled agents means tackling complex engineering tasks, like connecting to data sources, managing access controls, and building vector databases, challenges that every team faces repeatedly.
Simple AI agents often struggle in enterprise environments. They can't access recent information, miss private company data, and lack the context needed for accurate responses. This leads to generic advice, irrelevant recommendations, and even fabricated answers, which can create compliance and security risks for organizations. How retrieval augmented generation works. Retrieval augmented generation, or RAG, is a breakthrough that addresses these limitations. Instead of relying only on static training data, RAG connects AI agents to real-time organizational knowledge. Here's how it works. First, the system retrieves relevant content from company knowledge bases. Next, it augments the user's question with this factual context. Finally, the agent generates a response using both its training and the retrieved information. This process ensures that answers are accurate, up-to-date, and grounded in real company data.
The impact of RAG in enterprise AI. With RAG, organizations benefit from real-time updates, source transparency, and factual grounding. Agents stay current with policies and procedures. Users can verify sources, and responses are anchored in actual company content, reducing the risk of errors or misinformation. Enter Foundry IQ. Building RAG systems can be complex. Foundry IQ from Microsoft simplifies this by providing a ready-made knowledge platform, eliminating the need for custom technical solutions, and making advanced enterprise AI accessibly to more organizations. Building retrieval augmented generation, or RAG systems for AI agents is complex. You need to configure vector databases, set up embedding pipelines, and maintain search infrastructure. Multiply that by every agent you deploy, and the challenge grows. What is Foundry IQ? Foundry IQ is a managed knowledge platform for AI agents, built on Azure AI Search. Instead of building separate RAG systems, you create shared knowledge bases that any agent can access, streamlining your workflow. Organizing knowledge bases. With Foundry IQ, knowledge bases are organized by business domain, not storage location. Agents search product documentation or HR policies, regardless of whether the data lives in SharePoint, Azure Blob Storage, or OneLake. Connecting data sources. Foundry IQ integrates with your existing storage. It scans, processes, and indexes documents automatically. When you update a data source, every connected agent benefits instantly without extra configuration or code. Built-in retrieval intelligence. Foundry IQ uses intelligent retrieval strategies. It analyzes questions, selects the best search method, ranks results by relevance, and provides citations, all without custom code or manual tuning. The shared knowledge advantage. When you improve a knowledge base, every agent connected to it benefits. Foundry IQ lets organizations build consistent, scalable AI agent systems, focusing on agent experience instead of infrastructure. Introduction. Your AI agent is only as smart as the data it can access. Foundry IQ makes it easy to connect multiple data sources, ensuring your agent always has the right information for your unique needs. Data source types. Foundry IQ supports 6 main data source types: Azure AI Search Index, Azure Blob Storage, Web, SharePoint Remote, SharePoint Indexed, and Microsoft OneLake. Each source offers different benefits, depending on where your data lives and how you want to access it. Real-time versus internal sources. With real-time sources like Web and SharePoint Remote, your agent gets up-to-date information. Internal sources, such as SharePoint Indexed or OneLake, keep your proprietary data secure while providing rich context for your agent's answers. Azure AI Search Index. Azure AI Search Index is perfect for enterprise search, offering features like semantic ranking, custom scoring, and multi-language support. It's ideal if you already use Azure AI Search and need advanced search capabilities. Blob storage and web. Azure Blob Storage connects directly to your files, making documents instantly available. Web access lets your agent pull current public information using Bing, great for answering questions about recent events or trends. SharePoint and OneLake. SharePoint options offer either real-time or advanced index search, while Microsoft OneLake connects your agent to unstructured data in Microsoft Fabric, supporting analytics and research-driven responses.
Configuring how agents retrieve knowledge is crucial for delivering accurate, trustworthy answers. Even with a well-indexed knowledge base, poor retrieval setup leads to inconsistent or unreliable responses. The retrieval problem. Without proper configuration, agents might answer from generic training data, provide unverifiable information, or ideally, cite and ground answers in your documentation. Only the last approach is acceptable for enterprise use, ensuring accuracy and accountability. Writing effective instructions. Clear instructions are essential. Specify when to retrieve information, how to cite sources, and what to do if the answer is not found. For example, instruct agents to always search the knowledge base, never rely on training data, and include citations like, "You receive 15 days of paid time off annually. Doc ID 1, Employee Handbook 2024. Testing and evaluation. Systematically test agents with various queries, straightforward factual, synthesis across documents, questions outside the knowledge base, and ambiguous prompts. Good responses should be grounded, cited, relevant, and complete. Adjust instructions as needed to address gaps or inconsistencies. Tailoring for agent types. Different agents require different retrieval strategies. Customer support agents must prioritize accuracy and official documentation, while research assistants synthesize across sources and indicate confidence levels. Continuous improvement. Monitor real-world usage, track citation and fallback rates, and refine both instructions and content to ensure reliable, scalable knowledge retrieval.
Question 1. What is the primary advantage of Retrieval Augmented Generation, or RAG, over simple AI agents? RAG eliminates the need for large language models by relying entirely on document retrieval. RAG enables agents to ground responses in current organizational information and provide source transparency. RAG automatically retrains the language model whenever organizational documents change. Correct answer? B. Question 2. Which data source option provides real-time access to SharePoint content with Microsoft 365 governance? SharePoint Indexed, which pre-processes SharePoint content into Azure AI Search. SharePoint Remote, which queries SharePoint sites and libraries in real time. Azure Blob Storage, which connects to SharePoint files stored as blobs. Correct answer? B.
Question 3. What is the purpose of scoring profiles in Foundry IQ knowledge bases? To encrypt sensitive fields and protect confidential information during retrieval? To boost specific fields or attributes so more important results surface first? To configure how documents are chunked and embedded for semantic search?
Correct answer? B.
Question 4. Why is it critical to specify retrieval behavior in agent instructions? Without proper instructions, agents might answer from training data instead of the knowledge base, provide unverifiable responses, or fail to cite sources. Instructions determine the semantic ranking algorithm that Foundry IQ applies to search results. Instructions enable the agent to automatically update knowledge base content when it detects outdated information.
Correct answer? A.
Integrate your agent with Microsoft 365.
Imagine you have developed an AI agent in Microsoft Foundry that expertly answers questions about your company's policies and procedures. While it performs well in the Foundry playground, your team spends most of their time collaborating in Microsoft Teams. How can you bring your agent directly into their daily workflow? Publishing agents to Teams and Copilot. Microsoft Foundry offers built-in capabilities to publish your AI agents directly to Microsoft Teams and Microsoft 365 Copilot. This means your users can interact with custom agents right inside the tools they already use without switching applications. Whether you need a support agent for IT questions, a knowledge assistant for onboarding, or a specialized advisor, you can make these agents available exactly where your users work. Enhancing agents with WorkIQ.
With WorkIQ, you can give your agents access to Microsoft 365 data, such as emails, meetings, and documents. This enables your AI agents to provide even more relevant and personalized assistance, drawing from the information your team relies on every day. Testing and troubleshooting. After publishing, you can test and troubleshoot your integrated agents to ensure they work seamlessly within Microsoft 365. This helps guarantee a smooth experience for your users, keeping productivity high and support accessible.
When you build an agent in Microsoft Foundry, it starts as a development asset. Publishing transforms it into a managed Azure resource with its own endpoint, identity, and governance. This process creates an agent application, which provides a stable invocation URL and ensures user data isolation. Publishing to Microsoft 365. A key focus is integrating your agent with Microsoft 365, making it available in Teams and Copilot. Publishing to Microsoft 365 creates an Azure bot service resource to route messages, generates a Microsoft 365 publishing package, and registers a Microsoft Entra ID application for authentication. Your agent then becomes discoverable in the Teams Agent Store, ready for distribution across your organization.
Publishing methods and scopes. The simplest way to publish is directly from the Foundry portal, which automates resource creation and prepares your agent for distribution. For advanced needs, the Microsoft 365 Agents Toolkit supports custom single sign-on and complex deployment pipelines. When publishing, you can choose between shared scope for testing or organization scope for production deployments. Agent identity and permissions. Publishing assigns your agent a unique identity. Remember to configure permissions for any Azure services your agent needs, as development permissions do not transfer automatically. Prerequisites for publishing. Before publishing, ensure you have the right Azure roles, an eligible subscription, and a Microsoft 365 tenant that allows custom apps.
Before publishing your agent from Microsoft Foundry to Microsoft Teams, make sure you are ready. Test your agent thoroughly in the Foundry Playground to confirm it works as expected. Check that you have the right permissions, including the Azure AI Project Manager role for publishing and the Azure AI User role for testing. Also, ensure you can create resources in your Azure subscription and register applications in Microsoft Entra ID. Gather your agent's display name, description, icons, publisher details, and links for your privacy policy and terms of use. Never include sensitive information in these fields. Publishing steps. To publish, open the Microsoft Foundry portal and select your agent. Review its configuration, then click Publish. Choose Publish to Teams and Microsoft 365 Copilot. The portal will help you create an Azure bot service resource and generate application and tenant IDs. Fill in all required metadata, upload your icons, and enter publisher information. Select your publish scope, shared for quick testing or organization for wider deployment, which requires admin approval. Click Prepare Agent to package your agent. You can download the package for local testing or continue with direct distribution. Testing and approval. If you downloaded the package, upload it in Microsoft Teams under Apps, then Manage Your Apps. Test your agent's responses, accuracy, and performance. For organization scope, request admin approval in the Microsoft 365 Admin Center. Once approved, your agent appears in the Teams Agent Store for your organization. After publishing, assign necessary permissions to your agent's new identity in Azure. For updates, repeat the publishing process and republish the new version. The Microsoft 365 Agents Toolkit is designed for advanced integration scenarios where publishing directly from the Foundry portal is not enough. It offers developers more control and flexibility when connecting agents to Microsoft Teams and Microsoft 365 Copilot. When to use the Agents Toolkit. Consider the Agents Toolkit if your project needs custom single sign-on configuration, middleware for processing or logging, or multi-environment deployment with separate development, staging, and production setups. It is also ideal for organizations requiring advanced debugging and integration with continuous integration and deployment pipelines, such as GitHub Actions or Azure DevOps. Instead of publishing directly, you create a proxy application using the Agents Toolkit. This proxy sits between Microsoft 365 and your Foundry agent, handling messages from Teams or Copilot through Azure Bot Service. It processes requests with any custom middleware, forwards them to your agent, and returns responses, giving you full control over the message flow. Getting started. Install the Microsoft 365 Agents Toolkit extension in Visual Studio Code.
Use the wizard to create a new custom engine agent, configure connections to your Foundry agent, set up authentication, and add any needed middleware logic. Comparison and summary. Direct Foundry publishing is quick and code-free, best for standard deployments. The agent's toolkit requires more setup, but offers extensive customization and debugging, making it ideal for complex enterprise needs.
Microsoft WorkIQ connects AI assistants to your Microsoft 365 Copilot data, making workplace agents much smarter. By tapping into emails, meetings, documents, Teams messages, and people information, WorkIQ helps agents answer questions and provide relevant, accurate responses using natural language. How WorkIQ works. WorkIQ operates in two modes. In command line interface mode, you can run quick queries directly from your terminal, like find my recent documents about Q4 planning. In Model Context Protocol, or MCP, server mode, WorkIQ integrates with AI assistants such as GitHub Copilot in Visual Studio Code. This lets your assistant access workplace context automatically, so you get helpful suggestions and answers without extra steps. Security and permissions.
After publishing your agent, testing goes beyond the Foundry playground. Try your agent directly in Microsoft Teams to ensure the user interface displays responses correctly, authentication flows work, and response times are acceptable. Involve colleagues to test across desktop, web, and mobile Teams clients, as different users and platforms can reveal unexpected issues. Troubleshooting common issues. If your agent does not respond in Teams, check that the Azure bot service is running and properly configured. Review bot service logs for errors and confirm the agent is published with the correct package. If tools work in Foundry but fail in Teams, make sure the published agent identity has the necessary permissions in Azure. Monitoring and feedback. Ongoing monitoring is crucial. Use the Foundry portal to track metrics like request volume, response times, and error rates. If you have application insights set up, trace conversations, analyze error patterns, and set up alerts for anomalies. Establish feedback channels, such as a Teams channel or email, to gather user input and identify recurring problems. Iterating for improvement. When testing or feedback uncovers issues, update your agent in the Foundry portal and republish. For organization-wide deployments, check if tenant policies require admin reapproval for updates. Regular iteration ensures your agent continues to meet user needs and performs reliably over time.
Question 1. What Azure resource does the Foundry portal automatically create when you publish an agent to Microsoft Teams? Azure Functions, Azure Bot Service, Azure Cosmos DB, or Azure Logic Apps?
Correct answer? B.
Question 2. What is the main difference between shared scope and organization scope when publishing an agent? Shared scope requires more Azure resources. Organization scope requires admin approval before the agent is available to all users. Shared scope only works in the Foundry playground. Organization scope provides better agent performance.
Correct answer? B.
Question 3. What happens to tool permissions when you publish an agent from Foundry to Teams? Permissions are automatically transferred to the published agent. Tools are disabled after publishing. The published agent gets a new identity and needs permissions reassigned. Permissions only work in organization scope.
Correct answer C. What is Microsoft WorkIQ? A machine learning model for workplace analytics? A CLI and MCP server that connects AI agents to Microsoft 365 data? A replacement for Microsoft Teams? A Visual Studio Code extension for building agents?
Correct answer? B.
5. When should you consider using the Microsoft 365 Agents Toolkit instead of direct publishing from Foundry? For all production deployments? When you need custom SSO, middleware logic, or multi-environment deployment? When publishing to shared scope? When your agent doesn't use any tools?
Correct answer? B.
Build agent-driven workflows using Microsoft Foundry.
Modern artificial intelligence solutions often depend on multiple agents working together to analyze information, make decisions, and take action. In Microsoft Foundry, agent workflows orchestrate these complex interactions, combining agents, control flow, and runtime safeguards for reliable automation. Visual Workflow Builder. Foundry's Visual Workflow Builder lets you design and test these systems without extensive coding. On the canvas, you define how agents are called, how data moves between steps, and how decisions are made based on agent outputs. You can observe execution paths and inspect results in real time. Customer Support Automation example.
Imagine you were a developer automating customer support at a growing software-as-a-service company. Your team receives a steady stream of support tickets, from billing disputes to technical errors. With Foundry, you can combine multiple AI agents, conditional logic, and human-in-the-loop escalation to triage requests efficiently and safely. Key workflow concepts. Workflow nodes, variables, and agent outputs work together to control execution paths. Structured agent outputs and conditional logic help route requests to the right workflow steps, ensuring each ticket is handled appropriately. Advanced workflow features. You can implement loops to process multiple inputs, apply escalation patterns for uncertain cases, and use PowerFX expressions to manipulate data and control flow within your workflows.
Workflows in Microsoft Foundry offer a visual, declarative way to orchestrate artificial intelligence-driven actions. Instead of writing code, you define a sequence of steps that describe what should happen and when, letting the platform handle execution and state management. This approach is ideal for business processes that blend artificial intelligence reasoning, logic, and user interaction. How workflows operate. A workflow is made up of connected nodes, each performing a specific function. Some nodes invoke agents, while others evaluate conditions, manage data, or communicate with users. By arranging and configuring these nodes, you control how information flows and how decisions are made. This structure forms an execution path that determines how requests move through the system. Advantages and flexibility. One major advantage of workflows is their ability to coordinate multiple agents. While single-agent solutions may struggle with complex or ambiguous tasks, workflows combine agents with different responsibilities, such as classification, decision-making, and resolution into a unified process. Workflows can also pause for human input or escalate decisions, balancing automation with oversight for real-world reliability. Building with workflows. Understanding workflows and their purpose gives you the foundation to build, extend, and reason about agent-driven systems in Microsoft Foundry. This flexibility and control make workflows a powerful tool for scalable, robust automation.
When designing agent-driven solutions, the way you structure your workflow is just as important as the agents themselves. Microsoft Foundry offers several predefined workflow patterns to help you model these interactions clearly and consistently. Sequential workflow. A sequential workflow follows a fixed step-by-step path. Each node executes in order, passing its output to the next step. This approach is ideal for pipelines and multi-stage processes, such as validating input, enriching data, and generating a final response. Sequential workflows are predictable and easy to reason about, making them a great starting point for anyone learning how workflows operate. Human-in-the-loop workflow. A human-in-the-loop workflow introduces pauses where user input or approval is required before continuing. In this pattern, the workflow explicitly asks a question, waits for a response, and then resumes based on that input. This is especially useful when automation needs to be balanced with oversight, such as approvals, confirmations, or when missing context must be provided by a person. Group chat workflow. A group chat workflow enables dynamic orchestration across multiple agents. Instead of a fixed path, control shifts between agents based on context, rules, or results. This pattern is perfect for scenarios where specialized agents collaborate, like customer support or multi-domain question answering. Choosing the right pattern. By understanding these workflow patterns and their strengths, you can select the orchestration approach that best fits your scenario before you start designing your workflow.
Microsoft Foundry's Visual Designer lets you build workflows as a sequence of connected nodes, each representing a specific action. This visual approach makes it easy to understand orchestration logic and see how agents interact within a larger process, all from a blank canvas or a predefined pattern. Node types overview. There are several main node types in the workflow builder. Invoke nodes call AI agents for tasks like classification or recommendations. Flow nodes control execution paths, including if-else for branching, goto for jumping between steps, and for each for looping over lists. Data transformation nodes manage variables, assign values, reset or parse data, and ensure information flows correctly. Basic chat nodes interact with users, collecting input that can influence later decisions. The end node marks the workflow's conclusion and can return a final result.
Building and editing workflows. You can move nodes, insert new steps, and inspect configuration details directly on the canvas. Remember, workflows are not saved automatically, so save your changes regularly to preserve your design versions. Variables and data flow. Variables provide shared state across nodes, allowing outputs from one step to inform decisions or trigger actions in the next. Testing and tracing execution. Workflows run in a conversational context, letting you interact through the chat window. This helps you observe how inputs move through nodes and validate each step before adding complexity. Agents are the core reasoning components in a Microsoft Foundry workflow. By adding agents, you enable artificial intelligence-driven decision-making, classification, and response generation as part of a larger orchestration. Each agent is designed for a specific purpose, making workflows smarter and more adaptive. Configuring agents in workflows. To add an agent, insert an Invoke Agent node in your workflow. This node can reference an existing agent or let you create a new one directly in the workflow designer. The Invoke Agent Editor allows you to configure tools, knowledge bases, memory, and guardrails, tailoring the agent's behavior to your needs. When invoked, the agent receives context like user input or variables and returns a response for use in later steps. Reusability and modularity. Agents can be reused across multiple workflows, encouraging modular design. For example, a categorization agent might classify requests in several workflows, while different resolution agents handle follow-up actions. This separation of concerns makes workflows easier to maintain and evolve. Structured output and variables. Agents can generate natural language or structured outputs, such as JSON. Defining an output schema ensures predictable responses, which is especially useful for routing logic or variable assignment. Agent outputs can be stored in variables and referenced throughout the workflow. Transforming workflows. By thoughtfully configuring agents, you transform simple sequences into intelligent, adaptive workflows that respond dynamically to changing needs. PowerFX is a low-code language designed to make building workflows simple and intuitive. Inspired by Excel, it acts as the glue that connects different parts of a workflow, letting you manipulate data, evaluate conditions, and control execution without writing complex code. How PowerFX formulas work. At the heart of PowerFX are formulas that evaluate to values. These formulas can reference system variables, which provide context like the current activity or user information, and local variables, which store data captured during workflow execution. This allows workflows to adapt based on context and previous steps. Using conditions and loops. PowerFX shines in decision-making and automation. In if or else nodes, formulas evaluate conditions, such as checking if an agent's confidence score is above a threshold. Loops, like for each nodes, let you process multiple items, such as support tickets, by applying the same actions to each, without duplicating logic. Practical formula examples. You can use PowerFX to convert text to uppercase with upper local.input, sum numbers in a list using sum 10, 20, 30, or join names with concatenate local first name space local last name. Empowering dynamic workflows. With PowerFX, you create dynamic, data-driven workflows that are both powerful and easy to maintain.
Building a workflow with Microsoft Foundry is just the beginning. Real-world automation is an ongoing process, requiring regular updates to keep workflows reliable and adaptable as business needs or artificial intelligence models evolve. Visual and YAML representations. Microsoft Foundry offers two ways to represent workflows, a visual canvas and YAML, which stands for YAML Ain't Markup Language. The visual canvas is perfect for understanding the workflow at a glance, tracing execution paths, and collaborating with your team. YAML provides a textual format for advanced configuration, version tracking, and integration with source control. Any changes made in one view are instantly reflected in the other, ensuring consistency and flexibility.
Versioning and collaboration. Every time you save a workflow in Foundry, a new, unchangeable version is created. This versioning system acts as a safety net, letting you review, compare, or roll back to previous versions if needed. It also supports collaboration by tracking who made changes and why. Notes and documentation. You can attach notes directly to workflow nodes or sections. These notes explain design decisions, clarify variable usage, and provide essential context, making it easier for future maintainers to understand the workflow. Best practices for refinement. Regularly review workflows for unused nodes, document logic with notes, and use version history to validate updates. This approach ensures your workflows remain robust, maintainable, and ready for enterprise use.
Integrating workflow automation into your applications is easier than ever with the Azure AI Project Software Development Kit, or SDK. After designing workflows visually in the Microsoft Foundry portal, you can bring them directly into your codebase for seamless automation. Setting up integration. Start by saving your workflow in the Foundry portal, which generates a YAML definition. You can reference this workflow by name or download the YAML to include in your project.
To connect programmatically, use the AI Project Client, which manages authentication and provides access to the OpenAI-compatible API for executing workflows. Invoking workflows. To run a workflow, create a conversation context and invoke the workflow by its name. Pass inputs such as user questions, support ticket descriptions, or data payloads to drive the workflow's logic. For example, you might send a message like "Users can't reset their password from the mobile app" to trigger automated triage. Handling workflow events. With streaming enabled, your application receives real-time events as the workflow executes. Monitor progress, capture outputs, and respond to workflow actions instantly. For workflows requiring user input, simply send additional messages to continue execution. Benefits of integration. Integrating workflows enables AI-driven automation in web apps, APIs, batch processing, and custom interfaces, all while leveraging the flexibility of code and the power of visual design. Question 1. Which type of node in a Foundry workflow is used to invoke an AI agent? Logic node, agent node, data transformation node.
Correct answer? B.
Question 2. Which node type would you use to handle multiple tickets in a workflow without duplicating nodes? If-else node, for each node, send message node.
Correct answer? B.
Question 3. Which of the following best describes how structured agent outputs are used in workflows? They are ignored once generated since agents always handle routing automatically. They provide predictable data that can be stored in variables, evaluated with conditions, and trigger workflow steps. They replace the need for loops and if-else nodes.
Develop an AI agent with Microsoft Agent Framework. AI agents are changing the way applications interact with users and automate tasks. Unlike traditional programs, these agents use generative artificial intelligence to interpret data, make decisions, and complete tasks with minimal human intervention. By leveraging large language models, AI agents streamline complex workflows and are ideal for automating business processes. Microsoft Agent Framework and Foundry Overview. Developers can build AI agents using the Microsoft Agent Framework, an open-source software development kit that simplifies integrating artificial intelligence models into applications. The framework supports agents from multiple providers, including Microsoft Foundry, Azure OpenAI, Microsoft Copilot Studio, and Anthropic. This module focuses on Microsoft Foundry agents, which deliver enterprise-grade capabilities through the Microsoft Foundry Agent Service.
Building with Microsoft Foundry Agent Service. The Microsoft Foundry Agent Service is a fully managed platform that allows developers to securely build, deploy, and scale high-quality, extensible AI agents. With this service, there is no need to manage underlying compute or storage resources. The Microsoft Agent Framework enables rapid development of agents on Foundry, supporting natural language processing and built-in tools with just a few lines of code. Practical example and key takeaways. For example, you can create an AI agent that automatically formats and emails expense reports for employees. After completing this module, you will be able to connect to a Microsoft Foundry project, create Foundry agents, and integrate tool functions to extend your AI agent's capabilities.
An AI agent is a program that uses generative artificial intelligence to interpret data, make decisions, and perform tasks for users or applications. Unlike traditional software, AI agents can operate autonomously, handling complex workflows without constant human supervision. Microsoft Agent Framework Overview. Developers can build AI agents using various platforms, including the Microsoft Agent Framework. This open-source software development kit, or SDK, makes it easy to integrate advanced AI models into applications, enabling agents to use natural language processing and collaborate with other agents. Core components of the framework. The Microsoft Agent Framework includes several core components. Agents provide a consistent interface and support features like multi-agent orchestration and function calling. Chat providers connect to services such as Azure OpenAI and Anthropic. Function tools extend agent capabilities, while built-in tools offer features like code execution and web search. Microsoft Foundry Agents. Microsoft Foundry agents deliver enterprise-level capabilities, including secure Azure integration, advanced AI features, and persistent conversation management. These agents can automatically invoke tools and integrate with Azure services, making them ideal for complex business scenarios. Key concepts and flexibility.
The framework's flexible architecture supports autonomous, multi-agent behaviors, persistent conversation context, and seamless switching between providers, empowering developers to build anything from simple chatbots to robust, scalable business solutions.
Microsoft Foundry Agent is a powerful enterprise solution within the Microsoft Agent Framework, designed to deliver advanced conversational AI with seamless tool integration. It automatically manages tool calls and conversation history, making it easier for businesses to deploy intelligent agents without manual intervention or complex state management. Key features. This agent comes equipped with built-in tools like Code Interpreter, File Search, and Web Search. It also integrates smoothly with Azure AI Search, Azure Functions, and other Azure services. With secure thread management, conversation context is preserved, reducing the need for manual tracking. The Foundry agent supports custom functions, allowing you to extend its capabilities and connect with external APIs and services. To get started, create a Microsoft Foundry project and add its connection string to your Microsoft Agent Framework application. Set up authentication using Azure CLI credentials, then connect to your project with the Azure OpenAI Responses Client class. Finally, create an agent instance with your chosen instructions and tools to begin interacting. Core components. The Microsoft Foundry agent relies on several core components: Azure OpenAI Responses Client for secure connections, the agent class for conversation handling, agent session for managing conversation history, and robust authentication options. Together, these enable secure, scalable, and context-aware enterprise AI applications. The Microsoft Agent Framework empowers your AI agent to use tools, which are connections to APIs and services. These tools work through function calling, letting the AI perform tasks it could not do on its own. Built-in tools. Microsoft Foundry agents include built-in tools that are ready to use immediately. For example, the Code Interpreter executes Python code, File Search analyzes documents, and Web Search retrieves information from the internet. No extra setup is needed for these. Custom tools. You can also create custom function tools. Define a Python function and use the @tool decorator from the Microsoft Agent Framework to register it. Provide a clear name, description, and specify if approval is needed for tool calls. Use type annotations and detailed descriptions so the AI understands how to use your tool. Tool registration and invocation. Add your custom tools to the chat agent using the tools parameter. Once registered, the AI automatically decides when to call your tools based on the conversation context and your descriptions. Multiple tools can be added and the framework orchestrates which to use. Write clear descriptions, use proper type hints, handle errors gracefully, and keep each function focused on a specific task. This ensures your agent is powerful, reliable, and ready for real-world applications. Question 1. What are the key steps to create a Microsoft Foundry agent using the Microsoft Agent Framework? Deploy a custom AI model before creating an agent definition in the Azure portal. Initialize the agent by defining a model in the agent thread constructor. Create an Azure AI agent client, define a chat agent with instructions and tools, and create an agent thread for conversations.
Correct answer, C.
Question 2. Which component in the Microsoft Agent Framework manages conversation state and stores messages? Agent Thread, Chat Agent, Azure AI Agent Client.
Correct answer, A.
Question 3. How do you add custom functionality to a Microsoft Foundry agent in the Microsoft Agent Framework? Configure custom functions in the Azure portal and link them to the agent through connection strings. Create Python functions with proper type annotations and descriptions, then pass them to the chat agent's tools parameter. Modify the AI model's architecture to integrate the custom functionality directly.
Correct answer, B.
Orchestrate a multi-agent solution using the Microsoft Agent Framework. AI agents are transforming how we solve complex problems, but sometimes a single agent just is not enough. That is where multi-agent solutions come in, allowing several specialized agents to collaborate and tackle bigger challenges together. How multi-agent systems work in DevOps. Consider DevOps, where monitoring, troubleshooting, and deploying fixes are daily hurdles. In a multi-agent system, a monitoring agent uses natural language processing to scan logs and metrics, detecting anomalies and triggering alerts. Next, a root cause analysis agent correlates these anomalies with recent system changes, using machine learning or rules to pinpoint the issue. Once the root cause is found, an automated deployment agent interacts with continuous integration and continuous deployment pipelines to implement fixes or roll back changes. Finally, a reporting agent summarizes everything, sending detailed reports and notifications to stakeholders.
Each agent focuses on its specialty, but together, they streamline the entire DevOps process. Benefits and capabilities. This modular and scalable approach reduces manual intervention, improves efficiency, and ensures timely communication. Multi-agent systems are intelligent, adaptable, and designed to handle complex workflows that would overwhelm a single agent. Learning with the Microsoft Agent Framework. With the Microsoft Agent Framework, you can design, orchestrate, and build your own collaborative AI agents, explore orchestration patterns, and develop robust multi-agent solutions for real-world DevOps challenges.
The Microsoft Agent Framework is an open-source software development kit that empowers developers to integrate artificial intelligence models into their applications. With this framework, you can create AI-powered agents that work independently or collaborate with others to tackle complex tasks. Core components and architecture. At its core, the Microsoft Agent Framework offers a flexible architecture. Agents are intelligent entities that use large language models, tools, and conversation history to reason and execute tasks. The framework supports agent orchestration, allowing multiple agents to collaborate seamlessly using different orchestration patterns. This unified interface means you can switch between collaboration styles without rewriting your agent logic. Key features and capabilities. The framework includes chat clients that connect to various AI services, such as Azure OpenAI, and Anthropic through a common interface. Agents can extend their abilities with tools, integrating custom functions or built-in services like code interpretation, file search, and web search. Conversation management ensures agents remember previous interactions, adapting responses for a more personalized experience. Why choose the Microsoft Agent Framework? This provider-agnostic platform supports multi-agent collaboration and human-agent interaction. It enables agents to automate workflows, augment human decision-making, and build adaptable AI systems, from simple chatbots to complex enterprise solutions.
Introduction to multi-agent orchestration. The Microsoft Agent Framework SDK makes it easy to design and manage complex workflows using multiple specialized agents. Instead of relying on a single agent, you can orchestrate a team of agents, each with unique expertise, to solve real-world problems collaboratively. Why multi-agent orchestration matters? Single-agent systems are often limited by their narrow focus. Multi-agent orchestration lets you assign distinct skills to each agent, combine their outputs for better accuracy, and coordinate steps so each agent's work builds on the last. This approach enables more flexible, efficient, and scalable solutions. How workflows operate in the Microsoft Agent Framework. Workflows in the Microsoft Agent Framework are structured sequences of steps. Executors, which can be AI agents or custom logic, perform actions and pass results along edges that define the workflow's logic. Built-in events help developers monitor progress, track errors, and analyze performance.
Orchestration patterns and flexibility. The SDK supports several orchestration patterns: concurrent, sequential, handoff, group chat, and Magentic. Each pattern offers a different way to coordinate agents, whether you need parallel analysis, step-by-step refinement, dynamic handoffs, or collaborative conversations. Unified development and real-world impact. With a consistent interface and runtime management, the Microsoft Agent Framework SDK lets you quickly prototype, refine, and deploy intelligent multi-agent workflows for real-world applications.
The Microsoft Agent Framework SDK makes it easy to design and manage complex workflows using multiple AI agents. Instead of relying on a single agent, you can combine specialized agents, each with unique expertise, to solve real-world problems collaboratively and efficiently. Why multi-agent orchestration matters. Single-agent systems are often limited by their narrow focus. Multi-agent orchestration lets you assign distinct skills to each agent, combine their outputs for better accuracy, and coordinate steps so each agent's work builds on the last. This approach enables more flexible, scalable solutions. How workflows operate in the Microsoft Agent Framework. Workflows in the Microsoft Agent Framework are structured sequences of steps where agents and logic components interact to complete tasks. Executors perform actions, edges define message flow, and built-in events help monitor progress, track errors, and analyze performance throughout the workflow.
Orchestration patterns and flexibility. The SDK supports several orchestration patterns: concurrent for parallel tasks, sequential for step-by-step processes, handoff for dynamic control, group chat for collaborative conversations, and Magentic for manager-driven planning. Each pattern can be adapted to your domain and integrated into existing systems. Unified development and real-world impact. With a consistent interface and runtime features, the Microsoft Agent Framework SDK lets you quickly build, refine, and deploy collaborative AI workflows. This unified approach turns multiple agents into a cohesive, intelligent problem-solving team for real-world applications.
Sequential orchestration arranges agents in a pipeline where each agent processes a task one after another. The output from one agent becomes the input for the next, making this pattern perfect for workflows that require clear, step-by-step progress. When to use sequential orchestration? Use sequential orchestration when your workflow has multiple steps that must happen in a specific order, with each step relying on the previous one. This is ideal for document review, data transformation pipelines, or multi-stage reasoning, where each stage adds something essential for the next. When to avoid sequential orchestration. Avoid this pattern if stages can be run independently and in parallel, or if a single agent can handle the entire task. It is also not suitable when workflows require iteration, backtracking, or dynamic routing based on intermediate results. How to implement sequential orchestration. To implement sequential orchestration with the Microsoft Agent Framework SDK, set up your chat client, define agents with specific roles, and use the Sequential Builder class to create the workflow. Add agents as participants, build the workflow, and run it so each agent processes the task in order. Benefits and closing thoughts. Sequential orchestration ensures predictable, high-quality results through stepwise refinement, making it a powerful choice for complex, multi-agent tasks that require ordered collaboration.
Group chat orchestration brings together multiple AI agents, and sometimes a human, to collaborate in a single conversation. A central chat manager controls the flow, deciding which agent responds next and when to involve a human participant. When to use group chat orchestration. This pattern shines in scenarios where group discussion or iterative collaboration is essential. Use it for creative brainstorming, debates, decision-making, or complex problem-solving that benefits from multiple perspectives. It is also ideal for transparent, auditable conversations, since all outputs are collected in one thread. How group chat orchestration works. Each agent is assigned a specific role and expertise. The chat manager guides the conversation, ensuring agents take turns and, if needed, requests human input. The workflow runs all agents concurrently, collecting their responses and combining them into a single organized output. Maker-checker loops and customization. A common use case is the maker-checker loop, where one agent proposes solutions and another reviews them. You can customize the chat manager to control conversation flow, filter results, or determine when to end the discussion, tailoring it to your needs. Group chat orchestration enables dynamic, collaborative problem-solving with transparency and flexibility. While it requires careful management, it is perfect for tasks that benefit from diverse expertise and iterative feedback, especially using the Microsoft Agent Framework SDK.
Handoff orchestration in artificial intelligence allows AI agents to transfer control to one another based on the task context or user requests. Each agent can hand off the conversation to another agent with the right expertise, ensuring the best-suited agent handles each part of the task. This approach is ideal for situations where dynamic delegation is needed, such as customer support or expert systems. When to use handoff orchestration. Consider handoff orchestration when tasks require specialized knowledge, but the number or order of agents cannot be determined in advance. It is especially useful when expertise requirements emerge dynamically during processing, or when multiple domain problems need different specialists working sequentially. Clear signals or rules should indicate when an agent should transfer control. When to avoid handoff orchestration. Avoid this pattern if the agents in their order are known upfront and fixed, or if task routing is simple and rule-based. It is also not suitable when multiple operations must run simultaneously, or when poor routing decisions could frustrate users.
Implementing handoff orchestration. Using the Microsoft Agent Framework Software Development Kit, or SDK, you can implement handoff orchestration with control workflows. Each agent processes the task in sequence, and routing is managed using switch case logic based on classification results. This setup includes data models, chat clients, and specialized executor functions for each workflow step. Benefits and use cases. Handoff orchestration provides flexible, dynamic task routing among specialized AI agents. It is especially effective for complex, evolving tasks like customer support or multi-domain problem solving, ensuring each part is handled by the right expert.
Magentic orchestration is a flexible, multi-agent pattern designed for tackling complex, open-ended tasks. At its core is the Magentic Manager, which coordinates a team of specialized agents. This manager decides which agent should act next, adapting to the evolving context and task progress. How Magentic orchestration works.
The Magentic Manager maintains a shared context, tracks progress, and adapts workflows in real time. This approach breaks down complex problems, assigns subtasks, and iteratively refines solutions. A dynamic task ledger is built as the workflow progresses, recording goals, sub-goals, and execution plans. The process emphasizes both building a documented approach and delivering the final solution. When to use or avoid Magentic orchestration. Use Magentic orchestration when problems are complex, require multiple specialized agents, or need a documented plan for human review. Avoid it if the solution path is fixed, the task is simple, or speed is the top priority, as this method focuses on planning over rapid execution. Implementing Magentic orchestration with Microsoft Agent Framework. To implement, define specialized agents, set up event handling callbacks, and build the workflow using the Magentic Builder class. Configure the standard manager for collaboration, run the workflow, process events, and extract the final result, enabling dynamic, intelligent agent collaboration for evolving challenges.
Question 1. What's the first step in the Microsoft Agent Framework's unified orchestration workflow? Select and create an orchestration pattern. Define your agents and describe their capabilities. Start a runtime to manage execution.
Correct answer? B.
Question 2. For brainstorming and collaborative problem-solving among multiple agents, which orchestration pattern is most suitable? Group chat? Magentic? Sequential?
Correct answer? A.
Question 3. Which pattern dynamically transfers control between agents based on context or rules? Handoff, concurrent, sequential.
Correct answer? A. Discover Azure AI agents with A2A. AI agents are powerful tools, but many real-world tasks demand more than just a single agent working alone. When agents need to collaborate, especially across remote or distributed environments, managing their interactions can quickly become complicated and time-consuming. What is the A2A protocol? The agent-to-agent, or A2A protocol, is designed to solve this challenge. It provides a standardized framework for agent discovery, communication, and coordinated task execution. With A2A, you can easily manage connections to remote agents, delegate requests to the right agent, and ensure secure, seamless communication between them. A2A in action, a practical example. Consider a technical writer aiming to create engaging blog content. One AI agent specializes in generating article headlines, while another crafts detailed outlines. Thanks to A2A, a routing agent can coordinate the workflow. It sends the request to the headline agent, passes the result to the outline agent, and delivers the final outline to the user automatically using A2A. Implementing A2A with Azure AI agents. In this module, you will learn how to implement the A2A protocol using Azure AI agents. You will practice configuring a routing agent, registering remote agents, and building a workflow that enables multiple agents to collaborate efficiently and effectively.
The agent-to-agent, or A2A protocol, is a standardized way for artificial intelligence agents to communicate and collaborate. It defines how agents share context, invoke each other's capabilities, and exchange information securely, even across different vendors or platforms. Agent skills explained. Before joining multi-agent workflows, an A2A agent must explain what it can do. This is done through agent skills, which describe specific capabilities or functions. Each skill includes a unique identifier, a name, a detailed description, tags for discovery, examples, and supported data formats. Agent card overview. The agent card acts like a digital business card for your agent. It contains identity information, endpoint URLs, supported features, default input and output types, a list of skills, and authentication requirements. This structured document helps other agents or clients discover and interact with your agent. A2A offers enhanced collaboration by allowing agents from different systems to work together. Each agent can select its own large language model for requests, and integrated authentication ensures secure communication. This flexibility leads to more complex and integrated AI solutions. Putting it all together. Once skills are defined and the agent card is published, other agents can automatically discover and interact with your agent. Requests are routed to the right skill, and responses are returned in supported formats, enabling seamless multi-agent collaboration. The agent executor is a vital part of any agent-to-agent or A2A system. It acts as the bridge between the A2A protocol and your agent's unique business logic, ensuring requests are processed and responses are delivered smoothly. Core responsibilities.
At its core, the agent executor handles all incoming requests sent to your agent. It executes tasks requested by users or other agents, streams responses or sends individual messages back to the client, and manages task cancellation if supported. This interface ensures your agent can both receive and respond to requests efficiently. How the agent executor works. The agent executor typically defines two main operations: execute and cancel. The execute operation processes incoming requests, accesses details like user input or task context, and sends results back through an event queue. The cancel operation handles requests to stop ongoing tasks, though not all agents support this. Communication relies on the request context for understanding requests and the event queue for sending results. Importance in multi-agent systems. A well-implemented agent executor is essential for seamless integration and collaboration in multi-agent workflows. It standardizes how agents execute tasks and communicate, making your A2A agent functional and reliable in complex environments.
To make your A2A agent accessible to clients and other agents, you need to host it on a server. Hosting enables real-time interactions over HTTP, allowing your agent to participate in coordinated, multi-agent workflows and respond to requests as they arrive. Core components. Hosting an agent requires three essential components working together. First, the agent card describes your agent's skills and input or output modes and is exposed at a standard endpoint for easy discovery. Second, the request handler routes incoming A2A requests to your agent executor, managing the entire task lifecycle with a task store that tracks tasks and streaming data. Even simple agents need a task store for reliable interactions. Third, the server application, built with a web framework like Starlet in Python, handles HTTP requests and exposes the agent card and request handler endpoints. Setting up the server. To set up your agent server, define your agent's skills and agent card, initialize a request handler linked to a task store, and configure the server application. Start the server using an ASGI server, such as Uvicorn, to make your agent accessible on the network. A basic Hello World agent might offer a simple greeting skill, while more advanced agents can provide multiple skills or extended agent cards for authenticated users. This setup ensures reliable task management and seamless participation in multi-agent workflows. Once your A2A agent server is up and running, the next step is understanding how a client interacts with it. The client acts as the bridge between your application and the agent server, enabling seamless communication and task management. Connecting to the agent server. To connect, the client needs the base URL of your agent server. The first action is retrieving the agent card from a well-known endpoint. This agent card contains essential metadata about the agent and its available endpoints. With the agent card in hand, the client can initialize and establish a ready connection for sending messages.
Sending requests. Clients can send two main types of requests: non-streaming and streaming. Non-streaming requests are straightforward, where the client sends a message and waits for a complete response. Streaming requests, on the other hand, allow the client to receive incremental updates as the agent processes the request. Each request typically includes a read, such as user, and the message content. Handling responses. Agent responses may be direct messages or task-based objects. Direct messages provide immediate output, while task-based responses represent ongoing tasks that may require follow-up to check status or retrieve results. Clients should handle both types appropriately. By understanding these steps, connecting, sending requests, and handling responses, you can confidently interact with your A2A agent server, whether for simple messaging or managing complex asynchronous tasks.
Question 1. What is the primary role of an A2A server?
It executes business logic for the agent directly. It routes requests between clients and connected agents. It stores static agent responses for reuse. Correct answer: B. Question 2. What does the agent executor do in an A2A agent? Manages network connections between clients and servers? Processes incoming requests and generates responses or events. Provides a GUI for monitoring agent activity. Correct answer: B. Question 3. What is an agent card used for in A2A? It stores the agent's API key for authentication. It provides metadata about the agent, such as its capabilities and available functions. It visualizes the agent's workflow in a GUI dashboard. Correct answer: B.
Part 3. Develop natural language solutions in Azure. Analyze text with Azure Language in Foundry tools. Every day, enormous amounts of data are created, much of it as text. Think emails, social media posts, online reviews, and business documents. Extracting meaning from this text is essential for businesses and organizations. Azure Language in Foundry Tools Overview. The Azure Language in Foundry Tools offers an application programming interface, or API, that makes text analysis accessible. By applying artificial intelligence techniques, it uses statistical and semantic models to help you uncover insights and meaning from your text-based data. Integrating Azure Language with applications. You can easily integrate the Azure Language API into your own applications and agents. This enables you to build smarter solutions that understand and process language, making your software more powerful and insightful. Azure Language in Foundry Tools is a powerful solution for extracting information from text. It is designed to help you analyze language data efficiently, making it easier to understand and process large volumes of textual content. Key features. With Azure Language, you can detect the language of any text, recognize named entities such as people, locations, organizations, and time periods, and extract personally identifiable information, or PII, for privacy protection. Additional capabilities include sentiment analysis, summarization, and key phrase extraction, which are available to support existing applications. Getting started. To begin using Azure Language in Foundry Tools, you first need to provision a Microsoft Foundry resource within your Azure subscription. Once set up, you can access your resource's endpoint and key directly from the Foundry portal, making integration straightforward. Authentication methods. You can authenticate your requests using either the key associated with your Foundry resource or Microsoft Entra ID for enhanced security. Microsoft recommends using Entra ID authentication for production environments to ensure greater protection of your data. Programming language support. Azure Language APIs can be accessed through REST interfaces or programming language-specific software development kits, or SDKs, including Python, Microsoft C#, and JavaScript, following similar integration patterns. The Azure Language Detection API helps you identify the language of any text input, whether it is a single phrase or a full document. This is especially useful for applications or content stores where the language of incoming text is unknown. How the API works. When you submit text to the API, it analyzes each document and returns a language identifier, along with a confidence score between 0 and 1. The higher the score, the more certain the model is about its prediction. Each document must be under 5,120 characters, and you can submit up to 1,000 documents at a time. The API response includes the predicted language, its ISO 6391 code, and the confidence score. Practical examples. For instance, if you analyze Hello World and Bonjour le Monde, the API will return English and French as the primary languages, with high confidence scores like 0.9 and 0.98. This makes it easy to tailor your application's responses to the user's language. Handling ambiguity. If a document contains mixed languages or unclear content, the API may return a lower confidence score, or even mark the language as unknown with a score of 0. Named entity recognition, often called NER, is a powerful tool that identifies specific entities mentioned within a text. By analyzing sentences, NER can pinpoint names, places, dates, and more, helping to organize and extract valuable information from unstructured data. How named entity recognition works. NER works by scanning text and grouping identified entities into categories and subcategories. For instance, it can recognize a person's name, a location, or an organization. This process is similar to other Azure Language API functions, where you provide the text as input and receive a structured response highlighting the entities found. This makes it easier to process large volumes of text and quickly find key details. Categories and examples. Entities are sorted into categories such as person, location, date time, organization, address, email, and URL. For example, in the sentence, Microsoft was founded on April 4, 1975 by Bill Gates and Paul Allen in Albuquerque, New Mexico, NER identifies Microsoft as an organization, April 4, 1975 as date time, and Bill Gates as a person. Using Python, you can analyze documents and extract entities with just a few lines of code. The response will list each entity and its category, making it simple to organize and understand your data.
Protecting sensitive personal information is crucial when handling documents like customer feedback, medical records, or legal files. Before sharing these documents, it is important to remove personally identifiable information, or PII, to ensure privacy and compliance with data protection standards. How Azure Language identifies PII. Azure Language offers advanced PII detection and redaction capabilities. It can identify sensitive details such as names, addresses, phone numbers, email addresses, social security numbers, and credit card numbers. By submitting one or more documents for analysis, Azure Language extracts PII entities and provides their categories along with confidence scores, helping you understand exactly what information is considered sensitive. Redacting sensitive information. Once PII entities are detected, Azure Language can automatically redact them. The service returns a version of the text where sensitive information is replaced by asterisks or a character you specify. This ensures that private data is masked before documents are shared, reducing the risk of accidental exposure. Real-world example. For instance, if a document contains a name, email, or social security number, Azure Language will identify and mask these details. This makes it easy to protect privacy while still using valuable document content for analysis or sharing.
Question 1. How should you create an application that analyzes news articles and extracts key people, places, and dates that are mentioned for indexing? Use a generative AI model with a custom function tool that matches strings using a regular expression. Use Azure Language and Foundry tools to extract PII entities. Use Azure Language and Foundry tools to extract named entities.
Correct answer, C.
Question 2. You want to publish extracts from customer testimonials on a website. You need to remove personal details from the text before publishing it. What should you do? Use Azure Language and Foundry tools to find and redact PII entities. Use Azure Language and Foundry tools to detect the language and publish only the testimonials in English. Use a GPT 4.1 model to create new AI-generated customer reviews.
Correct answer, A.
Develop a text analysis agent with the Azure Language MCP server.
Azure Language in Foundry Tools brings powerful natural language processing, or NLP, capabilities to your applications with features like language detection, named entity recognition, and personally identifiable information extraction. You can analyze text data more efficiently and securely. How the MCP server simplifies NLP tasks. Traditionally, you might call each NLP capability separately using REST APIs or software development kits. However, the Azure Language Model Context Protocol Server, or MCP server, changes this approach. By connecting your AI agent to the MCP server, the agent can dynamically choose and use the right language tool for any user request. This means you do not need to write custom code for every single capability, making your workflow much simpler. Connecting and using Azure Language in Foundry. Imagine your company needs to analyze customer reviews written in multiple languages. With Azure Language and Foundry, your AI agent can detect the language, identify people and places, and redact personal details, all through one connection. In this module, you will learn how the MCP server works, how to connect it to an AI agent in Microsoft Foundry, and how to build a client application that interacts with the agent programmatically.
The Model Context Protocol, or MCP, is an open protocol that lets AI agents interact with external tools, data sources, and services. It uses a client-server architecture, making it easy for agents to discover and use new tools without hard coding them. How MCP works. In MCP, the host application runs the agent, while a client component manages connections to MCP servers. The server exposes tools and resources. When an agent connects, it receives a catalog of available tools and their descriptions, enabling dynamic tool discovery at runtime. Azure Language MCP Server capabilities. The Azure Language MCP Server brings Azure Language natural language processing capabilities to any MCP-compatible agent. It supports language detection, named entity recognition, personally identifiable information redaction, and text analytics for health. For example, it can identify languages, extract names and organizations, redact sensitive information, and label medical entities from clinical text. Tool selection process. When a user sends a prompt, the agent analyzes it, checks the available MCP tools, and selects the best match based on tool descriptions. The agent calls the selected tool, receives results, and combines them into a natural language response for the user. Ready to connect the Azure Language MCP server to your agent? Here is a quick guide to get you started, from setup in Microsoft Foundry to programmatic integration for advanced scenarios. Setting up the agent. First, create a project in the Microsoft Foundry portal. Deploy a model, such as GPT 4.1, and create an agent with clear instructions.
For example, instruct your agent. You are an AI agent that assists users by helping them analyze and summarize text. This sets the stage for tool integration. Connecting Azure Language MCP. Navigate to the Tools page in Foundry. Select Connect a Tool, choose Azure Language in Foundry Tools, and enter your Foundry resource name and key. Once connected, update your agent's instructions to use the Azure Language tool for text analysis tasks. Testing and using the agent. Test your agent in the Foundry Agent Playground. When you send a prompt, the agent identifies tasks, calls the Azure Language MCP tools, and returns a combined response. Review the logs to see which tools were used in their results. Programmatic integration. To use the agent in your application, leverage the Microsoft Foundry SDK. Reference your agent by name and send prompts programmatically. The agent processes requests, calls MCP tools, and returns results, streamlining text analysis for your users.
Question 1. What is the primary role of the Azure Language MCP server? To train and fine-tune custom language models for use by AI agents? To expose Azure Language text analysis capabilities as MCP tools for agents? To deploy and manage large language models in an Azure subscription?
Correct answer, B.
Question 2. How does an agent determine which Azure Language MCP tool to call when processing a user's prompt? The developer writes routing logic to direct each prompt to a specific tool. The agent matches the prompt to tool descriptions received from the MCP server. The MCP server analyzes the prompt and automatically routes it to a tool.
Correct answer, B.
Question 3. When building a Python client application, how do you reference a Foundry agent when calling the OpenAI Responses API? By passing the agent's API key as a request header to the endpoint? By specifying the agent name in the agent reference field in extra body? By passing the agent's endpoint URL as the model parameter value?
Correct answer, B.
Question 4. What authentication method is used when connecting the Azure Language MCP server to a Foundry agent? OAuth 2.0 authentication with a client certificate and tenant ID? Key-based authentication using the OCP-API-subscription key credential? Anonymous access that requires no authentication or credentials?
Correct answer, B.
Develop a speech-capable generative AI application.
Speech transcription and translation are transforming how we interact with technology, making communication more accessible and efficient for everyone. Practical applications. These capabilities help document spoken conversations in meetings, generate captions for videos, create audible user interfaces, and power hands-free AI assistants that read messages or emails aloud. Microsoft Foundry Overview. In this module, discover how Microsoft Foundry uses generative artificial intelligence models to seamlessly convert speech to text and text to speech.
Microsoft Foundry Models is a comprehensive catalog featuring generative artificial intelligence models from multiple providers. Each model offers unique capabilities and is optimized for specific use cases, making it easier to find the right fit. Finding the right model. To help you navigate the options, the Microsoft Foundry portal includes filter and search features. These tools allow you to quickly identify models that match your requirements, whether you need advanced language processing or specialized tasks. Speech-capable models. For speech-related needs, Microsoft Foundry offers models that transcribe speech to text and synthesize text to speech. This includes specialized speech-capable models from the GPT-4o family of OpenAI models.
Speech-to-text, also known as speech transcription, is the process of converting spoken words from audio files into written text. This technology is essential for making audio content accessible, searchable, and easier to analyze across various applications. How speech-to-text models work. To transcribe speech, audio content is submitted to a specialized model. The model listens to the audio and generates a text-based transcript of the spoken words. Some of the models that support speech-to-text operations include GPT-4-O Transcribe, GPT-4-O Mini Transcribe, and GPT-4-O Transcribe-Diarize. Using speech-to-text in your own application. If you want to use speech-to-text in your own application, you can leverage the Azure OpenAI client from the OpenAI Software Development Kit. By connecting to your Microsoft Foundry resource endpoint, you can upload an audio file and request a transcription. The model then processes the file and returns the transcript in text format, making integration straightforward for developers. Key considerations and model availability. It is important to note that model availability can vary by region. Always check the model regional availability table in the Microsoft Foundry documentation to ensure the model you need is supported in your area.
Speech-to-text technology streamlines the conversion of audio to text, making information more accessible and actionable for everyone.
Speech synthesis, also known as text-to-speech, is the process of converting written text into spoken audio. Unlike speech-to-text, which transcribes spoken words into text, speech synthesis takes your text and produces a natural-sounding voice output. How speech synthesis works. To generate speech, you submit your text to a specialized model. The model processes the input and returns an audio stream of the vocalized text. This technology is widely used in applications like virtual assistants, accessibility tools, and automated announcements, making digital content more accessible and engaging. Available models and regional availability. Popular models that support text-to-speech operations include GPT-4o TTS and GPT-4o Mini TTS. However, model availability can vary depending on your region. It is important to review the model regional availability table in the Microsoft Foundry documentation to ensure you have access to the right resources. Using text-to-speech with Azure OpenAI. You can use the Azure OpenAI client in the OpenAI Software Development Kit to connect to your Microsoft Foundry resource. By uploading your text to a text-to-speech model, you can generate speech with customizable voices and tones, such as an upbeat, excited delivery. Saving and using generated speech. Once the speech is generated, it can be saved as an audio file, like a WAV file, and used in your applications. This makes integrating speech synthesis into your projects straightforward and efficient.
Question 1. Which model can you use to generate text from speech? GPT-4.0 Mini, GPT-4.0 Mini TTS, GPT-4.0 Mini Transcribe?
Correct answer, C.
Question 2. Which model can you use to synthesize speech from text? GPT-4o Mini, GPT-4o Mini TTS, GPT-4o Mini Transcribe?
Correct answer, B.
Create speech-enabled apps with Azure Speech in Microsoft Foundry Tools. Azure Speech and Foundry Tools offer powerful APIs designed to help you build speech-enabled applications. With these tools, you can easily integrate advanced speech features into your software, making interactions more natural and accessible. Core capabilities, speech recognition and synthesis. 2 core capabilities stand out: speech-to-text and text-to-speech. The speech-to-text API enables speech recognition, allowing your application to accept spoken input from users. On the other hand, the text-to-speech API provides speech synthesis, so your application can deliver spoken output. These features are essential for creating applications that can listen and respond, making user experiences more engaging and interactive. SDK packages and flexibility. While the module's code examples are in Python, Azure Speech supports multiple software development kit packages. You can develop speech-enabled applications using Azure Speech for Python, Microsoft.NET, JavaScript, or Java. This flexibility ensures you can work in your preferred programming language while leveraging Azure's robust speech capabilities. Azure Speech and Foundry Tools brings powerful speech capabilities to your Microsoft Foundry projects. With these tools, you can easily add features like transcribing recorded calls or meetings, or even creating an AI assistant that reads text messages and emails aloud. How to set up Azure Speech and Foundry. To get started, you need to provision a Microsoft Foundry resource within your Azure subscription. Once your resource is set up, you'll use its endpoint to call Azure Language APIs from your code. Authentication is handled by providing the key associated with your Foundry resource. You can interact with these APIs using JSON requests to the REST interface or by using programming language-specific software development keys, or SDKs. Using the speech config object. The first step in connecting to Azure Speech is creating a speech config object. This object holds the connection details for your Foundry resource. For example, in Python, you can use the Azure Cognitive Services Speech SDK to create this object with your subscription key and endpoint. Accessing endpoints and keys. You can find your endpoint and key on the default homepage in the Foundry portal or in the Admin tab of the Operate page. These details are essential for authenticating and connecting your applications to Azure Speech services. Azure Speech and Foundry Tools brings powerful speech recognition capabilities to your applications using the Speech-to-Text Application Programming Interface, or API. Whether you are working in Python, C#, or another language, the process follows a consistent pattern. How speech recognition works. First, you create a speech config object. This holds the details needed to connect to your Foundry resource, like the endpoint or region and your access key. Next, you can use an audio config to specify the audio source. By default, this is your system's microphone, but you can also point to an audio file. With both configurations, you create a speech recognizer object, which acts as your client for the speech-to-text API. Example, transcribing audio with Python. For example, in Python, you import the Azure Cognitive Services Speech Software Development Kit, or SDK. You set up your speech config and audio config, then use the speech recognizer to transcribe audio. The recognize once async method processes the audio and returns a result. Handling results and errors. If the transcription is successful, the result contains the recognized text. If not, you can check the reason property to troubleshoot issues, such as no speech detected or an error that canceled the operation.
Azure Speech and Foundry Tools offers a powerful text-to-speech API, making it easy to convert written text into natural-sounding spoken audio. This technology is widely used in interactive, speech-enabled applications, providing seamless voice experiences for users. How the API works. To get started, developers use a speech config object, which holds the necessary information to connect to an Azure Speech resource, such as the location and key. Optionally, an audio config can be set to define where the synthesized speech will be played, whether through the default system speaker, an audio file, or directly as an audio stream. With these configurations, a speech synthesizer object is created, acting as the main interface to the text-to-speech API. Implementing speech synthesis. The speech synthesizer object provides methods like speak-text-async, which sends text to the Azure Speech Service and returns spoken audio. Developers can easily integrate this into their applications, allowing for dynamic voice responses and accessibility features. Handling results and output. After synthesis, the speech synthesis result object contains properties such as audio data and reason, indicating if the process was successful and providing access to the generated audio for playback or further processing.
When working with Azure Speech and Foundry tools, you can tailor the audio output to fit your needs using a speech config object. Azure Speech supports a variety of output formats for the synthesized audio stream. You can select the audio file type, sample rate, and bit depth that best suit your application. For instance, you might need a high-quality format for professional use or a more compressed format for faster streaming. Voice selection. Beyond audio format, Azure Speech offers a wide range of voices to personalize your speech-enabled applications. Each voice is identified by a unique name that includes the locale, a person's name, and other details. For example, the voice EN-US-Dragon HD Latest Neural represents an English voice from the United States with specific characteristics. This flexibility allows you to match the voice to your audience or brand identity. Practical example and resources. To set these options in Python, you would use code like speechconfig.setSpeechSynthesisOutputFormat equals speechsynthesisoutputformat.rif24kHz 16-bit mono PCM and speechconfig.speechsynthesisVoiceName equals N-US-Dragon HD Latest Neural. For a complete list of supported formats and voices, check the Azure Speech SDK documentation to ensure your application sounds exactly how you want.
The Azure Speech Software Development Kit, or SSML, lets you convert plain text into lifelike speech. But did you know you can take your voice output to the next level? With Speech Synthesis Markup Language, or SSML, you gain powerful control over how your words are spoken. What is SSML and what can it do? SSML is an XML-based syntax that allows you to fine-tune speech characteristics. You can specify a speaking style, like excited or cheerful, especially when using neural voices. SSML lets you insert pauses, define phonetic pronunciations for tricky words, and adjust prosody, which means changing pitch, timbre, or speaking rate. You can also use say-as rules to express text as dates, times, or phone numbers, and even insert recorded audio or background sounds. Example, using SSML for custom speech. For example, you can create a dialogue between two neural voices. One voice might say cheerfully, "I say tomato," while another responds, "I say tomato," but pronounced differently, followed by a pause and "let's call the whole thing off." How to use SSML with Azure Speech SDK. To use SSML, simply submit your SSML markup to the speech synthesizer object in your code. For instance, in Python, you can call speak_SSML async with your SSML string to generate customized speech output. Question 1. What information do you need from your Microsoft Foundry resource to consume it using the Azure Speech SDK? The endpoint and key. The primary and secondary keys. The Azure subscription ID and resource group name.
Correct answer? A.
Question 2. Which object should you use to specify that the speech input to be transcribed to text is in an audio file? Speech config, audio config, speech recognizer.
Correct answer? B.
Question 3. How can you change the voice used in speech synthesis? Specify a speech synthesis output format enumeration in the speech config object. Set the speech synthesis voice name property of the speech config object to the desired voice name. Specify a file name in the audio config object.
Correct answer? B.
Develop a speech agent with the Azure Speech MCP server.
Azure Speech and Foundry Tools brings advanced speech-to-text and text-to-speech capabilities right into your AI applications. With these features, you can easily transcribe audio into text or generate natural-sounding speech from written content, making your solutions more interactive and accessible. How Azure Speech MCP Server simplifies integration. You can access these speech features directly using the Speech Software Development Kit or REST APIs. However, there is an even more streamlined approach, the Azure Speech Model Context Protocol Server, or MCP server. By connecting the MCP server to your AI agent, you enable it to handle speech tasks based on natural language requests. This means you do not have to write custom code for every speech operation. The agent interprets user requests and manages transcription or synthesis automatically, making your development process faster and more efficient. Practical example, customer support calls. Imagine your company needs to process customer support calls. Your team can use the Azure Speech MCP server to transcribe recorded calls for analysis and generate audio responses for customers. This unified approach eliminates the need for separate integrations for each speech task.
Learning outcomes of the module.
In this module, you will discover how the Azure Speech MCP server works, how to connect it to an AI agent in Microsoft Foundry, and how to build a client application that interacts with the agent programmatically.
The Model Context Protocol, or MCP, is an open protocol that lets AI agents interact with external tools and services. Using a client-server architecture, MCP allows agents to discover and use new tools dynamically without needing hard-coded instructions. This flexibility means agents always have access to the latest tool definitions, making updates and maintenance much simpler. How Azure Speech MCP Server works. The Azure Speech MCP server connects AI agents to Azure Speech in Foundry tools through MCP. When an agent connects, it receives a catalog of available speech tools and their descriptions. The agent can then select the right tool based on the user's request, such as transcribing audio or generating speech. This dynamic tool discovery streamlines integration and keeps agents up to date with new capabilities. Speech capabilities and tool selection. The Azure Speech MCP server offers two main tools, speech-to-text, which converts audio files to text, and text-to-speech, which turns text into natural-sounding audio. The agent analyzes user prompts, checks available tools, and calls the appropriate one, all without manual routing logic. Storage and security essentials. Audio files are managed using Azure Blob Storage, accessed via a secure SaaS URL. Always treat SaaS URLs as secrets, use minimal permissions, and rotate keys regularly to keep your data safe. Ready to connect the Azure Speech MCP server to your agent? Here is a quick guide to get your AI agent transcribing and generating speech in just a few steps. Set up storage. First, create an Azure storage account and a blob container to store audio files. Generate a shared access signature or SaaS token with permissions to read, add, create, write, and list. Copy the SaaS URL securely as you will need it later. Create agent in Foundry. Next, in the Microsoft Foundry portal, create a project and deploy a model, such as GPT-4.4. Set up an agent with instructions to use Azure AI Speech for transcription and speech generation. Connect Speech MCP Server. Go to the Tools page in Foundry, select Connect a Tool, and choose Azure Speech. Enter your Foundry resource name, project key, and the SaaS URL for your blob container. Link the tool to your agent.
Test in Agent Playground. Use the Agent Playground to test text-to-speech and speech-to-text. Approve tool usage when prompted. The agent will generate audio files or transcribe speech, providing links to results in your blob container. Build a client application. For programmatic access, use the Microsoft Foundry SDK and OpenAI Responses API. Reference your agent by name to send prompts and receive speech or transcription results. Customization tips. Customize speech output by specifying neural voices, languages, phrase hints, or profanity filtering directly in your prompts for tailored results.
Question 1. What two core capabilities does the Azure Speech MCP server expose to agents? Language translation and text summarization. Speech-to-text recognition and text-to-speech synthesis. Named entity recognition and sentiment analysis. Correct answer? B. Question 2. Why does the Azure Speech MCP server require an Azure storage account? To store the agent's instructions and configuration settings, to store input audio files and output audio files generated by the speech tools, to cache the MCP server's tool definitions for faster discovery. Correct answer, B. Question 3. What credentials are needed when connecting the Azure Speech MCP server to a Foundry agent? An OAuth 2.0 token and a managed identity endpoint URL. A Foundry resource key and a SaaS URL for a blob container. A client certificate and the Azure subscription ID. Correct answer, B. Question 4. How can you specify a particular voice when using the text-to-speech tool through the agent? By configuring the voice in the MCP server settings before connecting. By including the voice name in your natural language prompt to the agent. By setting an environment variable in the client application code. Correct answer, B. Develop an Azure Speech Voice Live agent in Microsoft Foundry. Voice-enabled applications are changing the way we interact with technology, making conversations with devices more natural and intuitive. This module explores how to build real-time, interactive voice solutions using advanced tools and APIs. What is Azure Speech Voice Live API? The Voice Live API in Azure Speech, available through Foundry tools, enables low-latency, high-quality speech-to-speech interactions for voice agents. It is designed for developers who want scalable, efficient, and seamless voice-driven experiences without manually managing multiple components. Key implementation steps. You will learn to implement the Azure Speech Voice Live API for real-time, bi-directional communication, set up and configure agent sessions, and develop event handlers to create dynamic, interactive user experiences. Benefits for developers. Using Voice Live with a Foundry agent streamlines development, allowing you to focus on building engaging voice applications that respond instantly and naturally to users. The Voice Live API empowers developers to build voice-enabled applications with real-time, bi-directional communication. By leveraging WebSocket connections, it enables seamless audio and conversation management, making it ideal for interactive, responsive experiences. Key features and architecture. This API supports advanced features like speech recognition, text-to-speech synthesis, and avatar streaming. Real-time audio processing is available in multiple formats, including PCM16 and G.711. Developers can choose from OpenAI voices or Azure custom voices and benefit from built-in noise reduction and echo cancellation for clear communication. Authentication and endpoints. To connect, use either Microsoft Entra, which is a keyless, token-based authentication method, or an API key. Microsoft Entra requires assigning the cognitive services user role and generating a token with the correct scope. Endpoints vary depending on whether you connect to a Foundry project or directly to a model. Events and session configuration. Communication relies on JSON-formatted client and server events. Developers can dynamically update session settings, such as voice type, modalities, and audio formats using the session.update event. Proper event handling ensures smooth, real-time interactions. Real-time audio and avatar streaming. The API allows appending, committing, and clearing audio buffers for live processing. WebRTC-based avatar streaming supports video, animation, and blend shape settings, enabling engaging, interactive applications with high-quality audio and visuals. The Azure AI Voice Live Client Library for Python lets you build real-time speech-to-speech applications using the Azure AI Voice Live API. It streams microphone audio over a WebSocket and receives server events for responsive, interactive conversations. Authentication methods. To connect securely, you can authenticate using either an API key or a Microsoft Entra ID token. For quick starts or testing, an API key works well, but for production, Microsoft recommends using Microsoft Entra authentication with the default Azure credential class for enhanced security and easier management. Event handling and session example. Handling server events is crucial for a smooth user experience. For example, if a user interrupts the voice agent, the client should immediately stop playback to avoid the agent talking over the user. Events like session updates, speech start, audio responses, and errors can be managed in your async code. You can also configure sessions with custom instructions, audio formats, and turn detection settings, such as setting silence duration or prefix padding for voice activity detection. Async-only SDK and best practices. As of version 1.0.0, the SDK is async only. All code uses async and await syntax, so be sure to update your applications accordingly. For full details, check the Voice Live package reference. Creating a voice agent with Microsoft Foundry and Voice Live makes building conversational applications easier and more scalable. Instead of embedding instructions in your code, agents encapsulate logic and configuration, streamlining updates and supporting complex conversational flows. Creating and configuring the agent. You can create your agent in the Microsoft Foundry portal using the Agent Playground. Enable voice mode to integrate Voice Live, then configure language, voice, advanced voice activity detection, audio enhancement, and even add a visual avatar. If you prefer code, use the Foundry Agent Software Development Kit, or SDK for Python, to define your agent and include Voice Live settings like voice type, noise reduction, and echo cancellation. Integrating Voice Live. Voice Live settings allow you to fine-tune your agent's audio experience. Choose the language, set up advanced voice activity detection to handle interruptions, and enhance audio quality. You can also select the agent's voice, adjust tone and speaking rate, and enable interim responses while waiting for model replies. Using the agent in your application. To use your agent, build a client application that connects to the agent, configures audio hardware, and manages the Voice Live session. Implement classes to handle authentication, audio input and output, and process events like user speech and agent responses for a seamless conversational experience.
Question 1. What are the 2 authentication methods supported by the Voice Live API? OAuth 2.0 and JWT JSON Web Tokens? Basic authentication and API keys? Microsoft Entra keyless and API key?
Correct answer, C.
Question 2. Which protocol is used for avatar streaming integration in Voice Live API? HTTP2, WebRTC, gRPC?
Correct answer, B.
Question 3. How do you configure and test Voice Live agent integration in the Foundry portal? You can't. Voice Live is only accessible through the REST API or Python SDK. In the Azure Speech in Foundry Tools Voice Live Playground, enable voice mode in the Agent Playground.
Correct answer, C.
Question 4. How can you stop audio playback when a user interrupts the voice agent? You can't. The user must wait for the agent to finish. Handle the server event type input audio buffer speech started event. Reset the Voice Live session and clear the conversation history.
Correct answer, B.
Translate text and speech with Microsoft Foundry tools.
Across the globe, countless languages are spoken, making communication between different language speakers a vital part of many international solutions. Bridging these language gaps is essential for sharing information worldwide. The challenge of translation. Translating between languages is a specialized skill that can be both time-consuming and expensive. Human translators must understand not only vocabulary, but also the unique linguistic rules and idioms of each language. AI-powered solutions. Automated translation, also known as machine translation, helps reduce the time and costs involved in language conversion. At the core of these solutions are artificial intelligence models, which can process and translate both written documents and spoken language efficiently. Microsoft Foundry and AI translation. With Microsoft Foundry, developers can explore innovative ways to build AI-powered translation solutions, leveraging advanced software to create seamless communication experiences across languages and cultures.
Many large language models can generate output in multiple languages and even translate documents. But when it comes to truly comprehensive multi-language translation solutions, specialized tools are essential. That is where Microsoft Foundry steps in with its robust Foundry tools. Azure Translator in Foundry Tools. One key offering is Azure Translator, available within Foundry Tools. This service provides comprehensive text translation across a wide range of supported languages. Not only does it handle standard translations, but it also allows users to create custom translation models tailored to specific needs, making it highly adaptable. Azure Speech in Foundry Tools. Another powerful feature is Azure Speech, also part of Foundry Tools. This suite includes speech-to-text and speech-to-speech translation, supporting multiple languages simultaneously. It is designed to make spoken communication seamless, whether you are transcribing or translating conversations in real time. Integration and developer support. Both Azure Translator and Azure Speech are accessible through a Microsoft Foundry resource endpoint. They offer extensive application programming interfaces and language-specific software development kits, empowering developers to build comprehensive, scalable translation solutions for any project.
Azure Translator in Foundry Tools is a powerful API that lets you translate text between more than 90 languages. Whether you need to translate, transliterate, or even use custom models for domain-specific terms, Azure Translator has you covered. Using Azure Translator in Foundry. You can explore Azure Translator directly in the Microsoft Foundry portal. The portal offers playgrounds for both text and document translation, making it easy to compare results from the default translation model and large language models. You can also view sample code to help integrate Azure Translator into your own applications.
Connecting and authenticating. To use Azure Translator, connect your client to a REST endpoint with an authenticated connection. Endpoints include the global Azure Translator endpoint, regional endpoints like api-nam.cognitive.microsofttranslator.com, or a Foundry-specific resource endpoint. Authentication is handled using your Foundry API key. Translating and transliterating text. Translate text by specifying source and target languages, or let Azure Translator automatically detect the source language. For example, translating hola from Spanish to French returns bonjour. You can also transliterate scripts, such as converting Japanese hiragana into Latin script. Supported languages and SDKs. Azure Translator supports over 90 languages and offers SDKs for Python, .NET, Java, and JavaScript, making integration flexible and straightforward.
Azure Speech and Foundry Tools lets you build speech-enabled applications using powerful APIs. With the Speech Translation API, you can translate spoken input and return translations as text or speech, making your apps more accessible and interactive. Connecting and configuring. To get started, connect your application to an Azure Speech resource using the Speech Translation Config object. You can specify your Foundry resource's endpoint or region. Next, configure the source and target languages. For example, set the source to US English and add French and Japanese as target languages. Use the Audio Config object to capture audio from your system's microphone. Translating and synthesizing speech. Once configured, use the Translation Recognizer object to listen and translate speech. When you say hello, the system can output bonjour in French and konnichiwa in Japanese. For speech-to-speech translation, manually synthesize each translation using the Speech Synthesizer object, selecting language-specific voices for natural pronunciation. Event-based synthesis. For one-to-one translation, event-based synthesis lets you capture translated audio streams. Set the desired voice and translation config, handle the synthesizing event, and save the audio stream to a file. This approach is ideal for translating and playing back speech in a single target language.
Question 1. What function of an Azure Translator text translation client object should you use to convert the Chinese word ni hao to the English word hello? Get supported language. Translate. Transliterate. Correct answer? B. Question 2. What function of an Azure Translator text translation client object should you use to convert the Russian word spasibo in Cyrillic characters to S-P-A-S-I-B-O in Latin characters? Get supported language. Translate. Transliterate.
Correct answer, C.
Question 3. Which Azure Speech SDK object should you use to specify the languages into which you want speech translated? Speech config, speech translation config, audio config. Correct answer, B. Part 4. Extract insights from visual data on Azure. Develop a vision-enabled generative AI application.
Generative artificial intelligence models allow you to build chat-based applications that can reason over and respond to user input. Vision-enabled applications. While most input is text-based, new multimodal models are emerging that can also interpret and respond to visual information, expanding possibilities. Microsoft Foundry and multimodal solutions. In this module, you will learn how to use Microsoft Foundry to create generative artificial intelligence solutions that handle both text and image prompts. To work with prompts that include images, you need to deploy a multimodal generative artificial intelligence model. These models are designed to handle not just text-based input, but also image-based input, and sometimes even audio. Available models in Microsoft Foundry. Several multimodal models are available. These include Microsoft Phi-4-Multimodal-Instruct, OpenAI GPT-4.1, and OpenAI GPT-4-1-Mini. Each of these models supports both text and image inputs, making them ideal for a wide range of applications. Testing multimodal models. Once you have deployed a multimodal model, you can test it using the chat playground in the Microsoft Foundry portal. Here, you can upload an image from your local files and add text to prompt the model. Further learning. For more information about available models, check out the Microsoft Foundry Models Overview article in the Microsoft Foundry documentation. This resource provides detailed guidance on model capabilities and usage.
Developing a vision-based chat client app is similar to building a text-based chat client, but with one key difference. Prompts now include both text and image content. To get started, you need a connection to the endpoint where your multimodal model is deployed. Preparing image data. To include images in your prompts, you can either use a web-based image URL or load a local image file. For local files, read the image data and encode it in base 64 format.
Then create a data URL in the format image/jpeg/base64/image data, replacing JPEG with the correct image format if needed. This step ensures your image is ready to be sent to the model. Submitting prompts. When submitting prompts, you have two main options. If your model supports the Responses Application Programming Interface, or API, include both the text and image data in your request. For models that use the Chat Completions API, such as those on Azure OpenAI, follow a similar process by sending both the text and the image as part of your message payload. Processing responses. Once your prompt is submitted, process the model's response as you would with text-based chats. The model will analyze both the text and the image, then return a response you can display in your client app.
Question 1. Which kind of model can you use to respond to visual input? Only OpenAI GPT models? Embedding models? Multimodal models?
Correct answer, C.
Question 2. How can you submit a prompt that asks a model to analyze an image? Submit one prompt with an image-based message followed by another prompt with a text-based message. Submit a prompt that contains a multi-part user message containing both text content and image content. Submit the image as the system message and the instruction or question as the user message.
Correct answer, B.
Question 3. How can you include an image in a message? As a URL or as binary data? Only as a URL. Only as binary data.
Correct answer? A.
Generate images with AI. Microsoft Foundry lets you harness the power of language models to generate content from simple natural language prompts. Traditionally, this meant creating text, but the possibilities are rapidly expanding. Expanding beyond text. Now, with advancements like the OpenAI GPT Image 1 model, artificial intelligence can generate original graphical content. Just describe the image you want and the model creates it for you, opening up new creative opportunities. Real-world applications. This technology has a wide range of uses. You can create illustrations or photorealistic images for articles and marketing materials, design unique product or company logos, or generate any image you can describe. Learning opportunity. In this module, you will discover how to build an application that uses generative artificial intelligence to create original images, unlocking new ways to bring your ideas to life. Microsoft Foundry offers advanced image generation models that can create original images from natural language descriptions. These generative artificial intelligence, or AI models, are designed to turn your words into unique visuals, opening up new possibilities for creativity and content creation. Available models in Microsoft Foundry. Within Microsoft Foundry, you will find a variety of image generation models. Notably, the OpenAI GPT Image-1 series and the Black Forest Labs FLUX series are both supported. Each model brings its own strengths and capabilities, allowing users to choose the best fit for their specific needs and creative projects. How image generation works. Image generation models work by interpreting your natural language prompts and producing entirely new images. For example, if you provide a prompt like a robot eating spaghetti, the model will generate an original image based on that description. These images are not pulled from existing catalogs, they are created from scratch using the model's training data. Exploring and using models. To discover all available models, visit the model catalog in the Microsoft Foundry portal. You can filter by inference tasks such as text to image to find the right model for your project and start generating custom images with ease. To explore image generation models, start by creating a Microsoft Foundry project. The Microsoft Foundry portal offers a model playground for hands-on experimentation. Using the playground? Within the playground, you can submit prompts and instantly view the images generated by the model, making it easy to see results in real time. Customization options? Depending on model support, you can also specify the resolution of your generated images or provide a reference image for inspiration. Developers can use language-specific software development kits, or SDKs, to create applications that generate images with advanced models. For instance, the OpenAI Python SDK and the Azure OpenAI.NET SDK are popular choices for integrating image generation into client applications. Example, Python SDK in action. Let's look at an example using the OpenAI Python SDK. By submitting a prompt like a robot eating a cheeseburger to the model called flux1.contextpro, developers can request a unique image. The code specifies the number of images to generate and the desired resolution, such as one image at 1024 by 1024 pixels.
Saving the generated image. Once the image is generated, the result is returned as a binary stream. Developers can decode this data and save it as a file, like image.png, making it easy to use or share the generated image.
Question 1. You want to find a model in Microsoft Foundry to generate images. Which inference task should you filter by? Text to image to text, embeddings.
Correct answer? A.
Question 2. Which OpenAI API can you use with image generation models? Video, image, graphics.
Correct answer? B.
Generate videos with Microsoft Foundry.
Generative artificial intelligence is now transforming video creation, moving beyond just text and images to dynamic, creative video content. Sora 2 capabilities. With Sora 2 in Microsoft Foundry, you can generate realistic or imaginative video scenes from text prompts, reference images, or even remix existing videos for unique results. Learning outcomes. In this module, you will learn to deploy Sora 2, craft effective prompts, and build Python applications using the OpenAI Software Development Kit.
Sora 2 is an advanced artificial intelligence model from OpenAI designed to generate realistic and imaginative video scenes. Available through Microsoft Foundry, Sora 2 offers creators an all-in-one platform with intuitive controls and superior video quality for transforming ideas into compelling video content. Prerequisites. Before deploying Sora 2, make sure you have an active Azure subscription, access to the Microsoft Foundry portal, and a Foundry project where you have deployment permissions. These are essential to begin using the model for video generation. Deployment steps. To deploy Sora 2 in Microsoft Foundry, start by signing into the Foundry portal. Create or select your project from the landing page. Navigate to the Build section, then choose Models from the left-hand menu. Use the search bar or filters to locate the Sora-2 video generation model. Select Sora-2, click Deploy, and configure your deployment settings as needed. For more details on available models, consult the Model Catalog and Collections article in the Microsoft Foundry documentation. Sora 2 capabilities. Sora 2 enables text-to-video generation, image-to-video transformation, and video remixing for targeted edits. It also supports audio generation and output videos. Choose between portrait and landscape resolutions and generate videos lasting 4, 8, or 12 seconds.
With Sora 2, generating AI-powered videos is simple and flexible. Once your model is deployed, you can create videos by submitting a prompt and customizing settings like resolution, duration, and even reference images. Setting up and generating videos. To start, navigate to your deployed Sora 2 model in the Microsoft Foundry portal. Open the Playground tab, enter your prompt, and adjust settings such as landscape or portrait resolution and video length. Click Generate, and your video will be ready in 1 to 5 minutes, depending on complexity. Remember, shorter clips often yield better results. Crafting effective prompts. Think of your prompt as briefing a cinematographer. Be specific. Describe camera angles, subject details, actions, lighting, and style. For example, instead of a beautiful street at night, try wet asphalt, zebra crosswalk, neon signs reflecting in puddles. The more detail you provide, the more control you have over the final video. Using references and remixing. You can anchor your video's first frame with a reference image or remix an existing video by specifying targeted changes. This lets you refine your content without starting from scratch. Tips for best results. Keep prompts focused, use clear actions, and iterate. Each generation is a creative collaboration. Experiment and refine for the best outcome.
With the OpenAI Python Software Development Kit, or SDK, and Sora 2 in Microsoft Foundry, you can generate videos programmatically. The process is asynchronous, meaning you submit a job, check its status, and download the result when it is ready. Step-by-step, creating a video. To generate a video, start by creating a job with your desired prompt, video size, and duration. For example, you might prompt a robot walks through a rainy city street at dusk, neon signs reflecting in puddles, with a resolution of 1280 by 720 pixels for 4 seconds. After submitting, poll the job status until it is either completed, failed, or canceled. Once completed, download the video file. Using reference images. You can also generate a video from a reference image by passing it to the input reference parameter. The image's resolution must match the video's size. Note that images with human faces are currently rejected, so use landscapes, objects, or animated characters instead. Remixing existing videos. To modify an existing video, use the remix method and provide a new prompt, such as changing the color palette to warm sunset tones. Key considerations. Remember, you can run up to 2 video jobs at once. Completed videos are available for download for 24 hours.
prompts are moderated, and reference images must match the target resolution exactly.
Question 1. What video durations does Sora 2 support? 1 to 20 seconds in 1-second increments, 4, 8, or 12 seconds, any duration up to 60 seconds.
Correct answer, B. Question 2. What is required when using a reference image with Sora 2? The image must be smaller than 1 megabyte. The image resolution must match the target video size. The image must contain at least one human face.
Correct answer, B.
Question 3. What is the remix feature used for in Sora 2? Combining multiple videos into one, making targeted adjustments to an existing video without regenerating from scratch, adding background music to generated videos.
Correct answer, B.
Analyze images with content understanding. Extracting valuable information from images and documents can be challenging, especially when dealing with unstructured content. Azure Content Understanding uses generative artificial intelligence to analyze this content, making it easier to access important data. How it works. With Content Understanding, you simply define a schema that describes the data you want to extract. The service then processes your images and documents, returning structured data that is ready for use in your business processes. Applications and learning. This structured output can power automation workflows, analytics, and search applications. In this module, you will learn to analyze images using both pre-built and custom analyzers with Content Understanding. Azure Content Understanding is a Foundry tool that uses generative artificial intelligence to process and extract insights from a wide range of content, including documents, images, videos, and audio. It transforms unstructured data into structured, actionable output for automation and analytics. How it works. The framework processes content through several stages. First, it ingests source material, then uses analyzers to define extraction settings and field schemas. Technologies like optical character recognition, speech transcription, and layout detection convert unstructured input into normalized text and metadata. Finally, it generates structured key value pairs based on your schema. Key benefits. Content Understanding accelerates time to value by enabling straight-through processing of unstructured data. It simplifies workflows, standardizes extraction and classification, and provides easy field extraction without complex prompt engineering. Enhanced accuracy is achieved by using multiple artificial intelligence models to cross-validate information. Analyzers and customization. You can choose pre-built analyzers for common scenarios like invoice processing, or create custom analyzers tailored to your business needs. Configure the base analyzer type, select artificial intelligence models, define field schemas, and set options like confidence scoring and segmentation. Content Understanding is a powerful tool that analyzes images to extract structured data, identify visual elements, and generate descriptions. Whether you need to process receipts, invoices, or identity documents, it offers both pre-built and customizable analyzers for your needs. Supported image formats and pre-built analyzers. You can analyze images in formats like JPEG, PNG, BMP, TIFF, HEIF, and even PDF documents. Pre-built analyzers are available for common scenarios, such as extracting details from receipts, invoices, or ID documents, making it easy to get started quickly. Custom field schemas and extraction methods. For more tailored results, define a field schema describing the data you want. Each field can use extraction, classification, or generation methods. For example, you might extract a product name, classify its condition, or generate a scene description. Analyzing images and using confidence scores. After submitting an image for analysis, results include extracted fields, confidence scores, and grounding information. High confidence scores mean results can be trusted for automation, while lower scores may require human review for accuracy. Tips for better results and business impact. For best results, use high-quality, well-lit images with a clear subject. Content Understanding transforms visual content into actionable data, supporting document processing, inventory management, and quality inspection across various business scenarios.
Question 1. What is the purpose of grounding in Content Understanding? To connect Content Understanding to Azure Storage, to identify the specific regions in content where each value was extracted, to filter out harmful content from images.
Correct answer, B.
Question 2. What does a confidence score of 0.95 indicate for an extracted field? The extraction failed and needs manual review. The value can be trusted for automated processing. The field was classified rather than extracted. Correct answer, B.
Question 3. Which pre-built analyzer would you use to extract vendor names and item totals from a purchase receipt? Pre-built image, pre-built invoice, or pre-built receipt?
Correct answer, C.
Create a multimodal analysis solution with Azure Content Understanding.
The challenge of content assets. Organizations depend on information stored in documents, images, videos, and audio recordings. However, extracting valuable data from these content assets can be difficult, time-consuming, and often requires combining multiple technologies for different formats. Introducing Azure Content Understanding. Azure Content Understanding is a multimodal service designed to simplify this process. It enables organizations to create artificial intelligence-powered analyzers that can extract information from nearly any content format, streamlining workflows and reducing complexity. Exploring capabilities and customization. In this module, you will discover the capabilities of Azure Content Understanding and learn how to build custom analyzers tailored to your organization's unique content analysis needs.
Azure Content Understanding is a generative artificial intelligence service designed to extract insights and data from a wide range of content types. With this service, you can quickly build applications that analyze complex data and generate outputs to automate and optimize business processes. How to access and use Content Understanding? Content Understanding is available through Microsoft Foundry. To get started, you need to provision a Microsoft Foundry resource within your Azure subscription. You can develop and manage your solution in the Microsoft Foundry portal in Content Understanding Studio or by using the Content Understanding Application Programming Interface. Multimodal content analysis capabilities? This service enables multimodal content analysis, allowing you to extract information from documents, images, audio, and video. By using a single, consistent development process, you can build solutions that analyze multiple content types efficiently and effectively. Practical applications across content types? For documents and forms, Content Understanding can retrieve specific field values, such as extracting key data from invoices to automate payment processing. In images, it can identify objects or defects. For audio, it can summarize calls or determine sentiment. With video, it can extract key points or detect specific activities in recordings.
Content Understanding solutions help you extract specific information from content using an analyzer trained on a schema you define. These solutions use generative artificial intelligence to identify and extract data from documents, images, audio, or video with minimal training data. Setting up your project. To get started, create a Foundry resource and launch Content Understanding Studio. Here, you can create a new project, which provisions the necessary Azure resources, including storage and a key vault for sensitive information like credentials and keys. This setup ensures your solution is secure and scalable.
Defining the schema. Next, define a Content Understanding schema. Upload a sample file and use the schema editor to specify the fields you want to extract. Templates are available for different content types, making it easy to tailor your analyzer for documents, images, audio, or video. You can also label fields manually for improved accuracy. Building and testing the analyzer. With your schema in place, build the analyzer. Test it by running analysis on sample files to see extracted field values and the JSON output. Content Understanding Studio allows you to refine your schema and retest as needed for optimal results. Deployment and reinforcement. Once satisfied, deploy your analyzer. It becomes accessible to client applications through your Foundry resource endpoint. Continue refining your schema in Content Understanding Studio to create new versions and enhance your solution's capabilities over time.
The Content Understanding API offers a programmatic way to create, manage, and use analyzers for your projects. It is designed to help you automate content analysis tasks by integrating directly with your applications. How to authenticate and connect. To get started, your client application sends HTTP requests to the Content Understanding endpoint associated with your Microsoft Foundry resource. You will need to include an authorization key in the request header, which you can obtain from the Azure portal or the Microsoft Foundry portal. Alternatively, you can connect programmatically using your Entra ID.
Submitting content for analysis.
A common use case is submitting content to an existing analyzer. For example, you can send a post request with a JSON body specifying the URL of your document. If you prefer to send binary data directly, use the Analyze Binary operation instead. Once submitted, you will receive an operation ID representing your analysis task. Retrieving and interpreting results. After submitting your content, use the operation ID to check the status of your analysis by sending a GET request to the Analyzer Results endpoint. When the operation completes, you will receive a JSON payload with the analysis results tailored to your content and schema. Key tips and additional resources. Remember to poll for operation status until completion. For more details and advanced scenarios, consult the official reference documentation for the Content Understanding API.
Question 1. What kinds of AI solution is Azure Content Understanding designed to help you build? Chatbots that automatically translate between multiple spoken and written languages? Analyzers that extract information from documents, images, videos, and audio files? Image generators that create visualizations based on descriptions?
Correct answer? B.
Question 2. Which graphical tool should you use to create an Azure Content Understanding project? Microsoft Visual Studio, Azure Machine Learning Studio, Content Understanding Studio.
Correct answer? C.
3. What should you define for the information you want to extract from content? A schema, an index, a cluster.
Correct answer? A.
Create an Azure Content Understanding Client application. Azure Content Understanding is a multimodal service designed to make it easy to build AI-powered analyzers. These analyzers can extract information from documents, images, audio files, and videos. Key features. With Azure Content Understanding, you can analyze multiple content formats in one solution. It supports both the Python Software Development Kit, or SDK, and the Representational State Transfer Application Programming Interface, or REST API, for developing client applications. How to use. In this module, you will learn to write code that submits content files to an analyzer and processes the results using both the Python SDK and REST API. Learning more. To dive deeper, complete the Create a Multimodal Analysis Solution with Azure Content Understanding module.
Getting started with the Azure Content Understanding API is straightforward, but there are a few essential steps to follow before you can begin building intelligent applications that analyze and understand content at scale. Provisioning a Microsoft Foundry resource. First, you need a Microsoft Foundry resource in your Azure subscription. You can create this resource directly in the Azure portal, or by starting a Microsoft Foundry project, which includes the resource by default. Using a Foundry project also gives you access to visual tools for managing content understanding schemas and analyzers, making setup and management much easier. Connecting to the API. Once your resource is provisioned, you will need the Microsoft Foundry Resource Endpoint and one of its API keys to connect from your client application. These details are available in the Azure portal, or if you are using a Foundry project, on the project homepage in the Foundry portal. Setting up model deployments. Before using the API, make sure to set up default model deployments for your Foundry resource. Content Understanding requires GPT 4.1, GPT 4.1 Mini, and Text Embedding 3-large models. You can configure these in the Azure portal or via the API. Using the Python SDK. To use the Python SDK, install the Azure-AI-Content Understanding package with Python version 3.9 or later. Alternatively, you can interact with the REST API from any language that supports HTTP requests. If you want to extract specific information from documents, Content Understanding Studio makes it easy to create custom analyzers. You can use the visual interface or define your analyzer with a JSON schema for more control. Defining an analyzer schema. An analyzer schema defines which fields to extract or generate from your content. For example, a business card analyzer might extract a contact name and email address. In the schema, each field is described with its type, extraction method, and a short description. The schema also specifies which generative models to use, such as GPT 4.1 for completion and Text Embedding 3-large for embeddings. Creating an analyzer with Python SDK. Once your schema is ready, you can use the Python Software Development Kit, or SDK, to create the analyzer. The Content Understanding Client class provides a Begin Create Analyzer method. Just authenticate, define your analyzer, and call the method. When the operation completes, you will receive your analyzer's unique identifier. Creating an analyzer with REST API. Alternatively, submit your JSON schema directly with a put request to the REST API. The response includes a callback URL to check the status. Pull this URL until the operation finishes and your analyzer is ready to use.
The Azure Content Understanding API makes it easy to analyze files like documents, images, audio, and video. Whether you want to extract information from a business card or process a scanned document, this API streamlines the workflow. Submitting files for analysis. You can submit files for analysis by providing a URL to an internet-accessible file or uploading binary data directly. When you send a request, you specify which analyzer to use, such as a business card analyzer. The operation is asynchronous, so you receive an operation ID to track progress and retrieve results once the analysis is complete. Using the Python SDK. The Python Software Development Kit, or SDK, for content understanding simplifies the process. The Content Understanding Client class handles authentication, request formatting, and polling for results. Just call the Begin Analyze method and the SDK manages the rest, including waiting for the operation to finish. Using the REST API. Alternatively, you can use the REST API by sending HTTP requests with your API key. Submit your file's URL, receive an operation ID, and poll the endpoint until the analysis is done. The response is returned as a JSON payload. Retrieving and processing results. Results depend on the analyzer and file type. For example, analyzing a business card returns extracted fields like name and email address, along with document layout details. Simply parse the results to access the information you need. Question 1. What configuration values are needed to use the Azure Content Understanding API? The name of the resource group where the Azure service is deployed. The Azure subscription ID and tenant ID. The endpoint and key for the Foundry resource.
Correct answer, C.
Question 2. What must be specified when calling the Analyze method to extract fields from content? The name of the Foundry resource, the name of the analyzer, the operation location returned when the analyzer was created.
Correct answer, B.
Question 3. How are the extracted fields returned? As type-specific values, as a list of strings, as a single blob.
Correct answer? A.
Extract data with Azure Document Intelligence. Forms and documents are essential for sharing information across every industry, but manual data extraction can be time-consuming and error-prone. Whether it is processing invoices, receipts, or tax forms, organizations often spend countless hours entering data by hand, slowing down operations and increasing the risk of mistakes. How Azure Document Intelligence works. Azure Document Intelligence, a cloud-based service in Microsoft Foundry, offers a smarter way to automate data extraction. By using optical character recognition, or OCR, and advanced deep learning models, it can extract text, key value pairs, tables, and structured data from a wide range of forms and documents. This means you can quickly process thousands of documents each month, reducing manual effort and improving accuracy. Azure Document Intelligence provides pre-built models for common document types, general document analysis models for extracting text, and even lets you train custom models tailored to your specific forms. Key features and capabilities. With Azure Document Intelligence, you can explore and test models using the Document Intelligence Studio, extract data from standard documents with pre-built models, and train custom models for industry-specific needs. This flexibility makes it ideal for automating complex workflows. Getting started and requirements. To get started, you will need familiarity with Azure and the Azure portal, plus some programming experience with C# or Python.
Azure Document Intelligence is a cloud-based artificial intelligence service from Microsoft Foundry that uses optical character recognition, or OCR, and deep learning to extract text, key value pairs, selection marks, and tables from documents with impressive accuracy and minimal effort. How Azure Document Intelligence works. OCR technology captures the structure of documents by creating bounding boxes around detected objects in an image. These bounding boxes are recorded as coordinates, preserving the relationships from the original document. Azure Document Intelligence returns this data in a structured JSON format, making it easy to process and analyze. Pre-built and custom models. The service offers 3 main categories of document analysis models. Pre-built models extract information from common document types like invoices, receipts, and ID documents without any training. For business-specific forms, you can use custom models, including template and neural models, to achieve higher accuracy for varying layouts. Accessing the service. You can access Azure Document Intelligence through REST APIs, client library software development keys for Python, C#, Java, and JavaScript, the Document Intelligence Studio online tool, or the Microsoft Foundry portal for integration with other tools. Input requirements. Supported input formats include JPEG, PNG, BMP, PDF, and TIFF. Files must be under 500 megabytes for the standard tier, and image dimensions must range from 50 by 50 to 10,000 by 10,000 pixels.
Azure Document Intelligence Studio is a powerful online tool designed for visually exploring and integrating features from the Document Intelligence service. With its intuitive interface, users can analyze form layouts, extract data, and train custom models all in one place. Exploring pre-built model analysis. The studio lets you analyze documents using pre-built models for invoices, receipts, ID documents, and more. Simply create an Azure Document Intelligence resource, select your model, upload your document, and instantly review extracted fields and confidence scores. It's fast, accurate, and requires no coding. Building custom models visually. Need something tailored? The studio enables you to build, label, train, and test custom extraction models without manually creating JSON files. Upload sample forms to Azure Blob Storage, label fields visually, train your model, and test its accuracy all within the studio's streamlined workflow. Add-on capabilities and flexibility. Enhance your projects with optional features like high-resolution extraction, formula detection, font property extraction, barcode reading, and converting scanned documents into searchable PDFs. Some features may incur extra costs, so be sure to review pricing details. Getting started and next steps. Access the studio at documentintelligence.ai.azure.com and start transforming your document processing today. Explore, customize, and unlock new possibilities with Azure Document Intelligence Studio.
Azure Document Intelligence offers pre-built models that let you extract data from common forms without building or training your own models. These models are trained by Microsoft on large sets of sample documents, ensuring reliable results for standard document types. Core document analysis models. At the heart of these pre-built models are two main document analysis models. The read model extracts both printed and handwritten text, detects language, and distinguishes between handwriting and print. The layout model builds on this by detecting tables, selection marks like checkboxes, and document structure. It can even extract key value pairs, making it ideal for documents with complex layouts or merged table cells. Pre-built models for common documents. Azure provides pre-built models for a wide range of documents. For example, the invoice model extracts customer names, dates, and totals. There are models for receipts, bank statements, pay stubs, contracts, and even U.S. tax forms like the W-2 and 1040. Personal identification documents such as passports and driver's licenses are also supported. Key features and when to use. All pre-built models extract text, tables, key value pairs, and selection marks. If your document matches a common type, pre-built models save time and deliver accurate results. For unique or industry-specific forms, consider custom models instead.
When pre-built models do not fit your unique document types, Azure Document Intelligence lets you train custom models to extract exactly the data you need. By labeling sample documents, you teach the system to recognize your specific fields. Custom template models. Custom template models are ideal for structured forms with a consistent visual layout, like applications or questionnaires. They quickly extract labeled key value pairs, tables, and even signatures. Training is fast, supports over 100 languages, and is cost-effective, making template models a great starting point for uniform documents. Custom neural models. Custom neural models use deep learning to handle structured, semi-structured, and unstructured documents. They excel when layouts vary, offering higher accuracy, overlapping field extraction, and signature detection. While they take longer to train and use more resources, they are best for documents with format variation. Choosing the right model. Start with a custom template model if your forms look the same each time. If accuracy is not enough or your documents vary, switch to a custom neural model for better results. Training and using custom models. Train models by labeling sample forms and uploading them to Azure. Use the Analyze Document function with your model ID to extract data. For multiple form types, combine models into a composed model for automatic classification and extraction.
Question 1. You need to extract text and table structure from a set of documents that have varying formats. You don't need to identify specific labeled fields. Which document intelligence model should you use? The read model, the layout model, the invoice model.
Correct answer? B.
Question 2. You're building a custom model in Azure Document Intelligence. What training artifacts are required when training with the REST API? Only the sample form documents in a blob container, sample forms along with OCR.json, labels.json, and fields.json files in a blob container, a minimum of 100 labeled forms, and a trained classifier.
Correct answer? B.
Question 3. A company processes both invoices and receipts. They want a single endpoint that routes each document to the correct extraction model. What should they use? A custom neural model, a pre-built read model, a composed model, or a custom classifier paired with extraction models?
Correct answer? C.
Create a knowledge mining solution with Azure AI Search. Azure AI Search is a cloud-based service designed to help you extract, enrich, and explore information from a wide range of data sources. It empowers organizations to build intelligent search and knowledge mining solutions, making data more accessible and actionable. Indexing and enrichment. To get started, you connect Azure AI Search to your data sources and create indexes. The indexing process organizes your data, while built-in artificial intelligence skills can enrich it with valuable insights. These skills include language detection, key phrase extraction, and even image analysis, helping you uncover hidden patterns and meaning within your content. Querying and knowledge store. Once your index is ready, you can perform full-text searches, filter results, and retrieve relevant information quickly. The knowledge store feature allows you to persist in rich data, making it easy to analyze further or integrate with other systems for even greater value. Azure AI Search is a cloud-based platform designed to help organizations index and query data from a variety of sources. Whether your data is structured, semi-structured, or unstructured, Azure AI Search provides the tools and infrastructure needed to build powerful, scalable search solutions. Key features and capabilities. With Azure AI Search, you can index documents and data from multiple sources, making it easy to organize and retrieve information. The platform leverages artificial intelligence skills to enrich your data, such as extracting text from images using optical character recognition, or OCR, and detecting entities and key phrases through text analytics. These insights are stored in a knowledge store, allowing for further analysis and integration with other systems. The indexing process can also incorporate additional AI skills to derive even deeper insights from your data. Applications in knowledge mining. Azure AI Search is ideal for a range of applications. It can power enterprise search solutions, helping users find information quickly within websites or applications. It also supports retrieval augmented generation, or RAG, in generative AI applications by using vector-based indexes for grounding prompts. Focus on knowledge mining scenarios. In this module, we will focus on how Azure AI Search enables knowledge mining by extracting and inferring valuable insights from documents, supporting advanced data analytics and integration. Azure AI Search relies on a powerful process called indexing to make your data searchable. At its core, an index is a structured collection of your content, and it is created and updated by a component known as the indexer. The indexing process. The journey begins with a data source, such as an Azure Blob storage container or a database. The indexer automates the extraction of data fields through an enrichment pipeline. This pipeline uses document cracking to extract content and incrementally builds a hierarchical document, typically in JavaScript object notation or JSON format, containing all the necessary fields for the index. Document construction and enrichment. For each entity, the indexer creates a document that combines metadata and enriched fields. If your data includes images, the indexer can extract and normalize them into a collection. Skills, such as language detection or optical character recognition, analyze these fields and add their outputs, like detected language or extracted text, to the document structure. Mapping fields to the index. Finally, the indexer maps fields from the enriched document to the index. This mapping can be implicit, where fields with matching names are automatically linked, or explicit, where specific mappings or transformations are defined for greater control and flexibility. Azure AI Search transforms how you manage and enrich your data. At its core is an enrichment pipeline, orchestrated by an indexer, which uses a skill set of artificial intelligence skills to create AI-enriched fields. Each skill is applied in sequence, refining your index document step by step. Built-in skills. Azure AI Search offers a variety of built-in skills, powered by Foundry tools like Azure Vision and Azure Language. These skills can detect the language of your text, extract places and entities, identify key phrases, translate content, and even handle personally identifiable information. They also extract text from images and generate captions or tags to describe them. To use these built-in skills, your indexer needs access to a Foundry Tools resource. You can use a restricted Azure AI Search resource for small-scale indexing, or connect a Foundry Tools resource from your Azure subscription, as long as it is in the same region. Custom skills. For even more flexibility, you can create custom skills. These allow you to add your own logic to the enrichment process. For example, you might use an Azure function to connect your index document to an Azure Document Intelligence model, extracting specific fields from forms. Getting started. With Azure AI Search, you can combine built-in and custom skills to unlock powerful AI-driven insights from your data, making your search experience smarter and more efficient.
Azure AI Search Indexing transforms your data into a searchable index made up of JSON documents. Each document contains fields with values extracted during indexing, making it easy for client applications to query, filter, and sort information efficiently. Index fields. Every field in an Azure AI Search Index can be customized. Fields can be set as keys for unique identification, searchable for full-text queries, filterable for narrowing results, sortable for ordering, faceable for user-driven filtering, and retrievable for inclusion in search results. Full-text search. Azure AI Search uses full-text search, allowing users to find information by parsing document contents for query terms. It supports 2 Lucene query syntax variants, simple for basic searches and full for advanced filtering and complex queries. Query processing. When a query is submitted, Azure AI Search processes it in 4 stages: parsing the query, analyzing terms linguistically, retrieving matching documents, and scoring results based on relevance using term frequency and inverse document frequency calculations. Filtering and facets. Filtering can be done directly in search expressions or with OData filter parameters. Facetable fields enable users to refine results by selecting from discrete values, making it easier to navigate large datasets. Sorting results. By default, results are sorted by relevance, but you can specify sortable fields in order, such as listing the most recently modified documents first to tailor results to your needs.
Indexing is more than just creating a searchable list. The real value often lies in the enriched data produced during the process. This enriched data can open up new possibilities for how information is used and integrated. Uses of enriched data. The index itself is a collection of JSON objects, each representing an indexed record. These objects can be exported as JSON files, making them ideal for integration into data orchestration processes, such as extract, transform, and load operations, often called ETL. Additionally, you might want to normalize these records into relational tables for deeper analysis and reporting. Azure AI Search and Knowledge Store. Azure AI Search makes these scenarios possible by letting you define a knowledge store within your skill set. The knowledge store acts as a container for your enrichment pipeline, storing projections of enriched data as JSON objects, tables, or even image files. How projections work. Whenever an indexer runs the pipeline to create or update an index, these projections are automatically generated and saved in the knowledge store, ensuring your enriched data is always accessible for further use.
Question 1. Which component of an Azure AI Search solution is scheduled to extract and enrich data to populate an index? Indexer. Projection. Query.
Correct answer? A.
Question 2. Which service supports built-in AI skills in Azure AI Search? Azure Functions, Foundry Tools, Azure Cosmos DB.
Correct answer? B.
Question 3. Which kind of projection results in a relational data schema for extracted fields? File, object, table.
Correct answer? C.
Thanks for watching. If you haven't subscribed to our YouTube channel yet, we'd love for you to join our growing community. Just hit that subscribe button. Want a downloadable PDF of these questions and answers? You can grab it from our website, www.shapingpixel.com. Full link is in the description below. Happy learning!